Hi there. Thanks for your enrollment. We are in 1 minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy. And if you're going to enroll my courses, you will get 95% discount every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCI data center 3.0. Those are the new uploads as well. So please go continue your learning, take the coupon, enroll my courses, and study well. All the best. Hello, everyone. Thanks for your enrollment. You can go and enroll my courses over Udemy. You can go and subscribe me over YouTube as well. But either Udemy or YouTube, whenever you're watching my courses, obviously you are looking for the documents. So what I have done, I have created this giganetworkers.in blog site where I created different menus related to different courses that I have at various platforms. So for example, if you're looking for CCNP SD-WAN document, you can go here inside Cisco CCNP and can see that you have CCNP SD-WAN. You can go and click there, and then you will get all the documents related to CCNP. So once you scroll down here, so not only that I have uploaded the documents here, but you will get the video link as well. Now we reach to section 2. In this section, we have to learn about data center fabric infrastructure. Mainly, we have to understand about ACI. So what are the topic we have inside ACI to understand in this section? You can see that we should go and understand about physical fabric component, fabric discovery, switches, fabric policies, then tenant policy, and then we have few topics related to security monitoring. Okay, so I'm going to cover each and everything starting from here. One thing you can see in the end, 2.5 2.5a, clearly it is telling about virtual networking that I have already covered in our section 1. Remember when I have covered section 1, that is a pre-CCI, that is actually section number 2, because section number 1 is related to CCI and how we can start our journey in CCI from CCNA to CCI. So 2.5a I will not cover in this because we have already covered in our pre-CCI session. So I'm going to cover from 2.1 up to 2.4. All right, so let's start section number 2. Let us understand ACI Fundamentals. ACI is application-centric infrastructure. It is something like you have the leaf and spine structure, and all these leaf and spine backbone, they are managed via some controller called EPIC controller, application-centric controllers. Now the question arises here that why in the first place we need this type of a structure. Now you can think in the perspective of the developers. For developers, what they want, for application developers, they want that, okay, the client has some requirement for new application, they want to write new code, they want to deliver it as soon as possible. What are the constraints these developers have? These developers, by the end of the day, they are depending upon the network infrastructure. And in the traditional network infrastructure, what are the things we have? We have VLANs, subnet, protocols, ports,
routing constraints, security constraints, means we have barrier everywhere. It's not that the traditional network is there for application. Means network is there, you can write your application, the application will flow over the network, but it is not application based network. It's a network, on the top of that you're writing the applications. Correct? Now, considering these barriers into mind, this particular ACI infrastructure, that is application in the center infrastructure, has been developed. And if you see that ACI infrastructure, you will find that yes, exactly, we have different type of tiers like web, app, and DB. That is the three-tier application infrastructure. And then we have relationship like provider and consumer and the contracts in between them. In general, in short, that now the network is there to support applications. Means the application is in the core and then we are designing the network. That's the overall idea we have with the ACI. So what is ACI? In the old, IP endpoint based network, but in the new we have application based network. So initially we have IP based network, still we have IP based network, but all those constraints related to VLAN, subnet, port, protocol, security, those have been removed, and now you can think network as an application, and you can even you can change your network, like you have some programming structure or you have some template based structure from where you can change your network structure. Sometimes maybe you heard about some terms like now we have underlay and overlay type of network, and that's true. That's actually true, that you may have any type of physical connectivity in the bottom. So here in the down, you may have any type of connectivity, but the view of the network will be changed. So your underlay and your overlay. So this underlay has been abstracted, and when you are talking about the overlay view may be changed. So on the top or from the top, you can control your underlay or your physical infrastructure. So here you can see that, okay, I have option that I am doing application based networking. We have new software based network. We have software defined networking management. Now we are not declarative, but we are giving the promise to the customers. So now the new model is that, oh, you want to create 1,000 VLAN, I will create. You want to create 100 tenants, I will create. You want to create 1,000 subnets, I will create. Those things, like we can guarantee, we can promise to the customer that yes, we'll do, and we'll do it very, very fastly. Why? Because not only they are supporting various object model, but we can do the programming as well. Now finally you can see that's the pure SDN thing, that separation of control and the data plane, and that's true, that your data plane is somewhere, your control plane is somewhere, even you have your management plane as well, and from your management plane you are writing the code to the control plane, and by the end of the control plane pushes all these things to the data plane. It's like that. Now here you can see that ACI Fabric is an IP-based fabric that implements an integrated overlay that we have discussed, that we have underlay overlay, allowing any subnet to be placed anywhere. That's the true power, that now we are not fixed with the network. We have the mobility inside the network. That means that any subnet to be placed anywhere in the fabric and supports a fabric wide mobility. So now you can see that we have new capability for the subnets, that my subnets can move. So we have the mobility feature. For virtualized workloads, STP is not required within the ACI leaf and fabric. The spine and the epic doesn't run STP instances. So now we are in the complete ACI fabric, that is the leaf and spine type of structure. And here in the diagram you can see that you have the cloth fabric where you have leaf, spine, leaf, spine, leaf, spine type of a structure, and all these fabric we are managing or we are monitoring from the EPIC controller. Now in the core you can see that these devices they are running Nexus 9K, so either 9300 as a leaf, 9500 as a spine. This leaf and spine or this Nexus can run either in a standalone mode or in ACI mode. So we have dual benefit. Not only we have the dual benefit, but here in the points you can see that this particular switch actually this is best in the class efficiency. So its overall throughput, its performance, its uh, support to the programming, means you can program the ASICs, all those things has been very enhanced, very modernized, and that's why they are best in the class. So the Nexus 9K platform has two modes: standalone ACI. Nexus 9K utilize an enhanced version of NX OS operating system. That's the key. We have the enhanced version of the operating system to provide a traditional switching model with advanced automation and programming. So you can see now, because I have very good hardware, so I can do the programming. Because I have modern ASIC inside this, so I can do the automation programming. I can enable new capabilities. That's the key we have. In the second mode, that is the ACI mode in Nexus 9K, provides an application-centric representation of network as a whole. So here we have the application-centric infrastructure. If I run in the ACI mode, utilizing advanced feature and profile-based deployment, abstract the complexity of the underlay network and improving application visibility and greater business agility through the DevOps methodology. So you can see that how many key features we have inside the Nexus 9K box. Either it's a 9500 or it's a 9300, because of the advanced or enhanced ASIC that we have inside these boxes. They have much capability to run as a application centric infrastructure, to do the programming. It has more visibility and it has much better throughput as well. Now later we'll discuss about the application infrastructure inside the ACI. So for the moment, let's stop here and we can continue in the next section with some more theories of the ACI.
Hi there. Thanks for your enrollment. We are in 1 minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy. And if you're going to enroll my courses, you will get 95% discount every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCI data center 3.0. Those are the new uploads as well. So please go, continue your learning, take the coupon, enroll my courses, and study well. All the best. Next important section we have to learn about the Cisco ACI hardware. Now, what I will do that I'll break this session into two parts. So first of all, let us learn about the EPIC related hardware, and then we'll go and learn about the leaf and spine hardware. So now we know at this point of time that we have EPIC hardware, and that is nothing but UCS series blade server. The important point here to note is that we have generation 1, 2, and 3. So here you can see that we have generation 1, generation 2, and now we are inside the generation 3. For this generation, we have M3, that's the medium, L3, that's the large. So depending upon the deployment, we have the medium and the large server. Inside that, we have pre-installed EPIC software, and that is coming with the IMC or SIMC. That is nothing but Cisco Integrated Management Controller. Now, if you want to learn more about this, if you want to know more about this EPIC hardware, you please refer the data sheet. So you will come to know about different type of capabilities related to CPU, RAM, processing, how many, so for example, tenant it will support, how many endpoint, how many application profile, etc. So those number you will get in the data sheet, and according to that we can plan that what type of epic we want to use inside our data center deployment. Correct. So let us discuss quickly about the epic redundancy as well. Now we know that when we are doing the deployment for the epic, we should have minimum 3 epic in a cluster. Now, these epics we can go, and obviously we should have out of band management, and then these epics they are connected with leaf as well. So depending upon what type of redundancy we have, what type of design we have related to these epics, means how we are going to do the connection, that we can achieve the high availability. So here you can see that you have two connection. One is going towards the fabric, and that's very important. And then one connection we can use for out of band management as well. So while either you are going to the fabric or you have out of band management, both the cases you should have the redundancy. Now here we'll see that the redundancy will be there in the design, and for that reason we have the bonded interfaces. Those are dual home to two leaf, and this is the best practice that we are talking about. So we should have bond interface, and we should have dual homed connection. Obviously, if one link will go down, you have other link as a backup. Correct. So there are two bond interface. Say for example, bond 0 and bond 1. This bond 0, the connection with bond 0 is with the fabric, and bond 1 is with the out of band management. So straightforward, you first of all, as per your deployment, you have mark out that I'm going to use either M series or L series UCS blade server, depending on depending upon how many tenants, application profile, endpoints, user, edge port, etc. Once you have done that selection, then when you are connecting the interfaces, those steps are very important before doing the actual deployment, and you will see that there are some prerequisite. We should follow certain rule or certain steps before doing the actual installation. So what are that checklist that you can go and refer in the deployment section. So yeah, so once you have uh, completed the design aspect, your planning aspect. So your planning is done and you know that you are going for L or M epic. Then next you want to do the high availability redundancy design. For that you have bond 0 and bond 1. One is going to the fabric, other one is going to the out of band management. And here in the diagram, you can see that you have bond interface, and then you have bond 0 and bond 1. Obviously, one is going to the fabric and one is going for out of band management. Now, continuing the same strategy of high availability and redundancy, what we are doing that whenever we are deploying the epic controllers, we should have minimum 3 epic in a cluster, but is still, suppose if one of the epic will go down, suppose a hardware issue or any other issue. So at that time, just to prevent such type of events to be happen, what we are doing, that we should have one epic. So I have one epic ready as a standby, and suppose if this epic will go down, this epic which has the same software version, which has the same firmware, it will go and join the fabric, and then it will go and take the same chassis ID, same identity, and then the you can say that the replacement of epic is seamless. Correct. So that approach also we are using, and then for that approach I have completed steps. So for example, you should have minimum 3 epic in a cluster. Let me remove this marking and let me use this spotlight. So here you can see that you should have 3 in a cluster. One could have a standby epic, so anyone in that 3, you have one a standby epic as well, that is working as a standby mode. And when you want to do the replacement, either hardware failure or any issue, that particular epic, whenever you are upgrading the firmware for the active epic, at that time you are upgrading the firmware to the standby epic as well, the standby controller as well. So what will happen, that if one of the epic will go down, the backup will go and take the role. So here you can see that the backup has the same firmware version as the active cluster. Now each Cisco epic controller, active or standby, has an ID designated. I will show you in the lab. In the lab section, you'll see that these epic, they have certain ID. Now once this particular standby will take the role of active, he should go and take the ID name that is there used in the active as well. Correct. And this is the process by which we are changing the epic. We are changing the role of the epic, and then we are achieving the seamless type of you can say that disaster recovery, because one of the epic is down, obviously two databases or two remaining two epic will take the role, but still you don't want to risk with two. So that is standby will come and join the fabric, and again you have the three epic as per the standard. Great. We are into the part two of the hardware. We have just discussed about epic controller hardware, so which type of UCS blade server we have in that. Now next we have the leaf and spine hardware. Now for leaf and spine, we are using Nexus 9K or 9000 series, and that will be inside ACI mode. Remember, we have two mode, NX mode and then ACI mode. Now both modes are exclusive. Either you can use NX or you can use ACI mode. Now again, you will see that again we have two options actually, that either we can use the chassis model. So here you can see that you have the chassis architecture, or maybe you have fixed line card. Now you know that chassis means that you can replace the line card inside that. It has SOC, supervisor engine, redundant power supply, fan, means it has its own building structure. It has its own family as well. Correct. And then if you are looking for the cost and other aspect like the space, cooling, etc., you can go for the low end. So for example 9300 line card type of Nexus as well. So we have both the option, because Cisco was very popular, Cisco still is very popular with chassis based model. Either it's a catalyst switch or Nexus switch. Now, as per the customer requirement, as per the new virtualization requirement, Cisco is giving option related to line card based model as well. And again, you have pros and cons with the both. So if you have big deployment, obviously you will go for more number of ports, more port density, much more throughput, etc. And you can go and select this 9500, because remember, it is a big architecture, let me quickly show you that uh, how you can see this inside the animation. First of all, you can go and check the product family. So here you can see that you have 9500 modular switch, and then you have 9300 fixed switch. Again, you can go and check the data sheet, because if you go and verify the data sheet, you will get the information much more detailed, behind the scene things like what type of ASIC, how much support, how much throughput, what is the backplane, fan, redundancy, etc. Correct? So please go and refer these data sheet to learn more about the Nexus hardware. And what I'm going to show you next is that you can go to the animation as well. You can see the URL here. Even you can go and do simple Google search ACI Nexus hardware animation, and you will get these links. Once you are here, let me expand this. You can easily read all these things, and good thing about this is that these are the clickable item, so you can go and you can remove, even you can do some spin off, and you can see this animation. This is actually good if you don't have the physical hardware in front of you. You can go click on the top and you can see the front view. You can go and check any of the line card, and again you can see that since this is the modular chassis, so it has different type of line cards. So let me show you here that you have 64 port line card, that's the PX line card. So 9564, 64 stand for it has 64 ports. Then you have 64 port TX, then you have 36 PQ. So if I go and click 36 PQ, the first line card will go inside that, and then the next line card should come out and it will show you this. So there should be 36 PQ, and here you can see 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17. So 18 plus 18, you have total 36 port. And again you can rotate these diagrams. You can check the sync, RAM, CPU, the inside architecture. That is not very much relevant for the network engineers, but it's still in case of hardware failure, if you have certain type of error message, you can verify that if you know a little bit about the hardware as well. Now here you can see that you have the fan tray as well, and let me quickly show you that other stuffs as well. So you can go and check the fan tray, system controller, fabric module, etc. And even you can see the placement of those as well. Okay, so like that you can go and verify the hardware and the line card as well. Now this 9200 series Nexus switch is work or support only NX OS mode, which is not going to be used inside the ACI mode. Now rest of the things that you will see in this slide is just the representation or the theory behind how this architecture, this chassis or this modular chassis architecture look like. So for example, 9500 platform having 16 line card option, and it depends that what type of line card, what type of modular chassis architecture you have. Are you using 4 slot? Here you can see you have 4 slot. Are you using 8 slot? Here you can see 8 slot. And are you using 16 slot? Here you can see big 16 slot Nexus chassis. Correct. So likewise you have the nodes here, and again if I go back to the slide, you can see that overall throughput that you will get is going to be up to 400 gigi. You can see how much throughput it is. So now we are reaching from mbps to gigabit to terabyte, and you will see that uh, days will come that the devices, the hardware, the Nexus will support the much throughput in upcoming days. Now we know, and if you have work on the modular chassis, so you'll find that somewhere you have the control plane that's termed as a supervisor engine, and then you can put or insert the line card. So let me type here line card, line card, line card, etc. Line card you can think as a data plane, and supervisor you can think as a control plane, and in between this line card, so how the line card they are communicating with the supervisor engine. So that's the term we have is the EOBC, Ethernet out of band channel. This is the communication media between the line card and the supervisor engine. Again, small notes related to the power grid and the redundant power supply. Then all these modules nowadays, all the hardware, all the chassis, modular chassis switches, they are hot swappable. You can remove anything and you can insert anything. They have the fabric design. So actually inside that design you have cloth fabric. Remember that leaf spine type of a structure you will find inside the chip itself. So if you go and check the chip and the fabric module, they have the some crossbar architecture, and they are actually very much supporting the cloth fabric behind the scene. Again, if you want to learn more about the hardware inside Cisco Live, there are great presentation about ACI hardware, and you can go and just search the ACI hardware and you'll get good document related to in-depth uh, light on ACI hardware, and plus you will get some additional informations about different type of line card, different type of product family related to ACI plus the Nexus as well. So again, the front and the rear view you can see, and we have seen in the animation as well. You have the line card, you have the supervisor module, you have a fan tray, fabric module. That's something who is giving the actual throughput to the hardware. That's the fab module. And then you have the system controller. After that, you'll find that we have 9300 switches, and 9300 switches, if you go and check the first slide, that's very important. So you have this 9500 switches, and then you have 9300 switches. This 9300 switch, they can be used as a leaf and a spine, correct? So this 9500 is actually used as a spine. So here you can see that it's not mentioned, but it is used as a spine. But just 9300 and different hardware inside 9300 family can be used as a leaf and a spine as well. So we should check the data sheet that which particular version is used for what, correct? Now let's quickly move on and reach to the slide where we are. So now you can see that you have different type of line card as well, and inside this 9364 you can see uh, these are the hardware which is supporting the spine switch. So this is clearly mentioned that these hardware 9364, 9332, 36 and 16, they can work as a ACI spine switch. And then if I go next, again you can go and check the rack space and all the other features and throughput. Next, if I can go here, you can see that we have the 9336FX2, 93180 is very popular as a leaf switch, and 9332 that is also very popular with a leaf switch. So they are used as a leaf switch. So there is a version difference, 9364, 9332C. These things you should write somewhere and you can compare it. Maybe in Excel sheet you can check that, okay, which hardware, how much interfaces, because with the name itself you will come to know how many interfaces. So 9336 means 36 port, you can count here. Then 180 doesn't mean 180 port, but it is telling you that 24 into 40, 6 into 40, like that. Then 32 PQ is 32 port, like that. Okay, so again, these are the uh, leaf switch series, and again you can see the supported throughput. I have marked that as a green. How much rack space it will use, how many SFP port or QSFP plus port it will use. Again, we have two generation. One is EX series, one is FX series, and again, as per the throughput, as per the port density and the speed, we can utilize these inside our system. So you can go to this link and you can further study about the hardware and the architecture about this. Either it's a chassis or it's a leaf or switch line card type of ACI switch. One thing I want to mention here is about the ASIC. ASIC is playing a very important role, and we have two different generation. Now we are inside the Cisco type of ASIC. And here you will find this is actually the summary of these two slides. So if you go and read these slides carefully, uh, what will happen with the evolution of a new type of ASIC is that you are getting the higher bandwidth, greater port density at lower price. You have large buffer size, you have large table size, means you can put more MAC address, IP address, etc. And then they have the visibility and telemetry support. Now if you come here, you'll see that starting with the generation 1, you have NFE and ALE, means when a packet will come, it has to recirculate among the NFE and the ALE. Now we have the leaf spine engine, you can say LSE, where in the single circulation it will happen, and it's very much enhanced. That's the second generation, and inside 9300 you can go and use this second generation. All right, so if you want to know more, again, I have given this link here in the bottom. So you can go and just check that what are different type of chip we have, this NFE and ALE, network forwarding engine or application leaf engine, etc. You can go and check the name and a few of the features that is used, but again you can see that the same thing is happened with two different ASIC that is collapsed inside one ASIC. So obviously the recirculation will not happen, and the request will come to LSE, leaf spine engine, and then it will hand off for the next processing. Correct? Great. So we have completed the hardware study at this point of time. In the previous section, we have a study about the EPIC, and then we have a study about the ACI leaf and spine hardware. The next section, I'm going to start about the ACI object model. And for that, I have 4 different videos. So go and complete those 4 videos related to ACI object model.
Let us discuss the ACI Bring Up Process, and you'll see the various steps here while we are doing the ACI Bring Up. First of all, we should connect all these leaf, spine and the EPIC controllers. So all the equipment has been racked and stacked. All fabric links between the leaf and spine has been connected. All management and console connection has been connected. So make sure that all the interfaces are connected properly. And what's the rule behind to connect these interfaces? They are connected like this. EPIC should be dual connected through. So here you can see that I have EPIC connected dual homed through the leaf switch, and they are using the 10 gig interface. Now, very interesting that we have something called infrastructure VLAN. So for example, I will use 4093. That is not recommended to use 4093, but for example, I'm using infra VLAN 4093. That should be non-overlapping with the existing VLAN in my ACI infrastructure. So I'm not going to use this VLAN inside any of either local or global scoped VLAN in the ACI infra. The tip, that is the tunnel endpoint IP. We'll discuss more and more about the TEP addresses in the upcoming sections. We need to understand what is meaning of endpoint and how with help of endpoint the traffic is flowing from one tip to other tip. That is actually the VTIP, VXLAN tunnel endpoint. At the moment, the tunnel endpoint is like loopback address to the leaf nodes. So I have, say, tip addresses here. Now this tip address pool should not overlap the existing IP address pool, and that's true. So suppose if I am giving the tip address pool, say for example 10.1, so say 10.1.0.0/16, then you should not use these addresses inside the infra. The same thing like for VLAN, same thing like for tip addresses. We should give some unique subnets or the VLAN for these. Now, the epic discover the IP address of the other epic in the cluster using the LLDP based discovery mechanism. So that's the other thing that we have to understand here, that how this discovery process happening. In the upcoming video, we'll discuss more about this. But what is happening in general, that epic will discover the leaf, and then leaf will discover the spine, and then this process will continue. Okay. All right. So let's see what other mechanisms and theory behind this. The epic communicates with the Cisco ACI Fabric through a VLAN that is associated with the tenant infra, and for that we are using infra VLAN. That's okay. At the time of bring up process, it will ask you, oh, what is your infra VLAN? What is your TEP address? What is your OOB address? What is your gateway, etc. Here in the diagram, you can see the sequence of the boot up process. So epic, they are using the LLDP process. After that, you can see the DHCP discover request, DHCP process is going on, and then we have the HTTP process to get the firmware, and then we have the IFM policy, IFM management policies for policy elements. So first of all, they will discover the devices with LLDP mechanism. The infrastructure VLAN number is chosen at the time of provisioning, yes. While the booting up the system, it will ask you. This VLAN is used for internal connectivity between the epic spine leaf and the switches. Yeah. So epic, they will search leaf, then a spine, and then this process will carry on. Cisco ACI uses layer 3 link in the fabric. So inside the ACI fabric, where I have leaf and a spine, obviously here I have the fabric. They're using the L3 because all these are L3 links. Inside the fabric, everything is routable. Fully managed by Cisco ACI, the traffic is tagged with the infrastructure VLAN. So suppose if you want to extend, if you want to go outside from your fabric, then you are using the infra VLAN. And what's the example for this? So this, the example for this is when you are using application virtual switch. So from your ACI fabric, you want to go outside. At that time, you have to use the infra VLAN, and actually that's very important point here. So suppose in other hand, if you have to deploy AVS switch, what is the requirement? So requirement is that you are going to use the infra VLAN for AVS integration. Okay, so the infrastructure VLAN must be extended between the leaf and the AVS software switch. That's correct. So I need to, I'm going to use the infra VLAN for my AVS integration, application virtual switch integration. Okay, let's cover other points as well. A Cisco ACI Fabric uses a LLDP based and the DHCP based Fabric Discovery to automatically discover the fabric switch nodes, assign the TEP address, and install the firmware to the switches. That's the same diagram that we have seen here. So now you can mark that in between epic and the switch, what type of protocols has been used. So they are using LLDP, they are using DHCP, and then HTTP methods, and then they are pushing the policy with the IFM mechanism. Some of the things you can see, the two-way means two-way communication. We have epic switch and epic switch, LLDP, DHCP, etc. But IFM is like one way. From epic I am pushing the policy to the switches. All right, so now we are understanding more about this ACI bring up, and we need to highlight these things while we are doing this study. So I can list out the number of important points while we are bringing up the fabric. Next point, the tip address pool is critical part of configuration. You should choose a non-overlapping API range. Yes. So for example, I have choose 10.1.0.0/16 TEP, your tunnel endpoint addresses. The node get IP address from the epic, then it asks to download the firmware through the HTTP GET method. All right. That is also okay and straightforward. Let's carry on and see last slide related to this. So what are the other things we have here? Epic are equipped with two 10 gig NIC. Okay, we know this thing. We have done the connectivity like this. These NICs should be connected to different leaf nodes for redundancy. So I have my Epic controller and I have connected. You can connect like this. All right. So Epic connectivity is automatically configured for active backup teaming, which means that only one interface is active at the given time. You can verify but do not modify this from the bash shell. So you can go to the bash shell, you can see that who is the active, who is the backup. Assuming that the infra VLAN is 4093, then what type of interfaces we have? We have bond 0 interface. This is the NIC bonding interface in the in-band connection to the leaf switch. No IP address is assigned to this interface. So let's stop here, and in the next section I will log into the Epic and I'll show you all these interfaces, and then that will make sense that what type of interfaces we have while we are doing the bring up process. So let's stop here. Let us continue where we left off. So what type of bonds you have means what type of NICs and the bondings they have. Assuming that the VLAN ID is 4093, the network interfaces are as follow. First of all, I have bond 0. This is the NIC bonding interface for in-band connection. It don't have any IP address. Then I have bond into my intra VLAN. This sub-interface connects to the leaf switch. The VLAN ID is 4093. During the initial bring up process, we have to put that. This interface obtains dynamic IP from the TIP, tunnel endpoint addresses. All right, and apart from that, you'll find that we have say bond 1. This is the NIC bonding. So if we have NIC bonding, then you will see bond 1. For the OOB management, no IP is assigned to this. And then finally, you have the OOB management, out of band management IP, to access the Epic. When bring up the Epic, you enter the management IP for OOB management. So what are the things you are giving? Say for example, you are giving the infra VLAN, you are giving the TEP pool, you are giving the OOB management IP pool, you are giving the gateway, etc. So at that time you have to give this IP, and the OOB management interface will take that IP address. So let us log into the Epic, say Epic 1 controller, and let us verify these things. At least we can see most of the interfaces in our Epic controller. So let me go here, and first of all let me type say ACI diag fnb read. What this command will do, with help of this command you can see that whatever leaves you have, what is the serial number, what is the TEP address. So here I am using pool, say for example 10.0.0.0/8, and then we have /32 addresses to all the leaves and the spines. So these are my tip that I can see here. And this ACI diag fnb, that is the fabric node vector read. This command is actually very useful to get these addresses. Let us suppose if you want to SSH to any of the leaf or the switch or leaf of the spine, then you can go and give the IP, say for example the username and the IP, and then you can give the password and you are in. Okay, so like that we can do the SSH. Anyways, let's go and verify that what type of interfaces we have. So I can go and check interface config. Even I can go and grep the interface, but let's see. So I can see here that I have interfaces first of all related to Epic. interfaces epic eth1, eth3, loopback 0, but we have the bond 0. So here you can see the bond 0. I don't have any IP address. Then bond 0.4, I have the TEP address. Correct? That is 10.0.0.0.1. That is assigned automatically from the fabric. Then I have 0.5, where I have this address. And then we have the loopback interface and the host IP or loopback IP for the system. So actually the system that we have logged in at the moment, it is a simulator. This is the Epic simulator that you can download from Cisco site and you can use, and you can go and check few of the reference interfaces we have. It's very much like what we have in the production, but it's a simulation where you can go and verify most of the things related to Epic or ACI infrastructure. Alright, so let's just stop here, and next section we'll study more about the bring up process. ACI Fabric Discovery is a very simple process. Once you connect all this spine with the leaves and the Epic controller, then what you can do, you can power on the first Epic controller, open the SIMC that with virtual KVM or the KVM we have, and then we have to provide the initial question and answer things. So what are the things it will ask you? That it will ask you, okay, I want to know the cluster information. So is it a ACI Fabric 1, 2, 3, like that? You can see, you can give the number. So suppose this is a fabric of 3, I can go and assign, I have 3 devices in the cluster, so you can give that. Then what is the controller ID? Okay, yes. What's the name? Epic 1. Enter the TEP address. So by default you can see it is 10.0.0.0/16. If this is overlapping with your internal IP, then you can go for 11. The infra VLAN, then it will ask you about the infra VLAN. By default it will be 4094. So for example, this case we are using 3967. Then enter the address pool for BD multicast. By default you can go and enter, it will take this default address. If you have any address you can put it. Then again it is asking about out of band management. So out of band IPv4 default address is this. If you want you can change it. What's the gateway? And that's it. Once you give all this information, after that you have to give the password. Once you give the password, then it will push all this configuration and then it will reboot, means it will start the initialization. It will take approx 5 minutes to do the initialization. Then what we need to do, we can go to the GUI itself. So here you can see that power on, then open the SIMC virtual KVM, answer initial setup. Once you do this, then you can go to the browser, and then what will happen, you will find that it will start searching or registering all the leaf and the spine. So it will start searching on the leaf and the spine. What we need to do there, that we have to go there and provide the name for those leaf and spines. So obviously you have the serial number and the name in your mind that you want to provide. So once my controller will start searching all the devices one by one, so what will happen, nodes are registered by the Fabric admin through GUI or API. Adding them into the Fabric node vector database, the following information is required. Serial number, automatically detected. Node ID, it will start from above 100. Node name, unique to the Fabric. So how it look like, let me show you that once this discovery process start and it will start populating all the serial number, what you have to do, you can go here and provide the names. So it will search, is it a leaf or is it says spine? Means the role it will search like spine, and leaf, etc. But you need to check that, okay, this is the spine, what's the name? Obviously it will automatically take the TEP addresses. So it will take the TEP address, but as per the serial number you have to put the host name as per your datasheet that you have. So once you will do all this process, automatically it will populate, it will search, and it will build the fabric as per the connection. So finally, by the end of day, you will find that you will get this list, and here you have the TEP addresses, the role, what's the model, and then you have given the name and the serial number that they automatically detect. So once your fabric is built up and running, inside this fabric, the ISIS will be used as a IP reachability from the spine and the leaves, or in between the spine and leaves. So here you can see the ISIS is enabled in the infra to discover routing topology and the node reachability and never exposed externally. Means this is ISIS something used internally, and if you want to verify the ISIS database, the ISIS host name and other ISIS related things, you can go to the spine and leaves and you can check that. So here you can see that like OSPF, ISIS, they have built the database, they have built the routing table, adjacency table, etc. So we can go and check these commands. Alright, so now you can see that this fabric discovery process is very easy in ACI. Even if you have 10 nodes or if you have 200 nodes, doesn't matter. This is the way that Cisco has built this ACI fabric, that the discovery process is fairly simple, and you can build your data center. Means the basic steps, means your fabric can be bringed up within hours if you have even hundreds or more than hundreds of leaves and spine. So let me go and log into the URL that we have. So let me show you that once you discover all these devices, how they look like. So what we can do now, that we can go to the fabric, and inside fabric we can go to the inventory. Inside inventory you can see that we have options that we can check: the pod fabric setup policy, fabric membership, duplicate IP, and disable interface and decommission. I can go inside the fabric membership. Here you can see that, okay, I have the serial number because this is the simulator, or this is, you can say, the emulator to learn the ACI fabric. The serial numbers are some non-related serial numbers, but in general, in your environment, in the production environment, you will see the serial numbers, those unique serial numbers that will become with the uh, devices, normal, like in normal Cisco routers or normal Cisco switches. Alright, so I can see here the serial number, the model, and then I have to go and give the name like leaf 1 or leaf 2, spine 1, spine 2, etc. We can see the TEP address. So this is the way that fabric can be built. Now we have construct of ACI, means what are the building blocks for ACI. On the top view, if you see that in ACI actually have two types of component. So what are the components we have in ACI? One should be logical, other one should be physical. Now we know all these SDN solution, whatever we have in the market, that you have the control plane, you have the data plane. So let me draw here so you can understand more on this. That means you have data plane who is doing the actual data forwarding, and that you can think that, okay, that is your underlay devices, and then you can abstract those things to the overlay. So that means if you have some physical connectivity, those physical connectivity, it can be seen in other view, or maybe I have different views of that physical connection over the overlay to these underlay. So that's the reason you'll find that, okay, in all the SDN solution, for example, ACI also, you have two types of things. One is the logical, means one part will be the logical, one is the physical. Now, if you see the overall fabric structure, you'll find that, okay, I have the management plane called the EPIC controller, from where I can manage the spine and the leaf infrastructure. So I have a spine, leaf means cross fabric I have. I can manage entire fabric, correct? Now, when you are thinking or when you're seeing this spine and leaf structure, and then you have some edge devices, maybe Nexus 7K or maybe some other devices. So all these connections obviously related to fabric, they are physical connection. You can create template and you can reuse those templates over same type of interfaces. Either it's connected here, or maybe you have n number of leaf nodes. So spine and the leaf, n number of leaf nodes you have, you can use those configuration. The other portion that I have is the logical configuration, and that I want to highlight here in the, you can see in the diagram that, okay, I have the logical construct, that is tenant, that may represent customer, business unit or group of some logical entities. Now these tenants are part of virtual routing forwarding. You can see here VRF and the context. Then they are part of bridge domain. This bridge domain you can think as a VLAN, for example. These VLANs have some subnets. Now again you can see that these particular VLANs, they are tied with endpoint group. Now, what is endpoint group? Where I have the endpoint. What is endpoint? Where I have the virtual or the physical systems. So overall the structure, you can see that, okay, you can create the template, you can push the configuration, you have some logical entity, you have some physical entity. In between logical and the physical entity, you have some sort of a glue, something that will join the physical and the logical uh, construct, or the physical and the logical configurations. And yes, we have glue name as AAEP, attachable access entity point, something like that. You can refer the ACI documents. So what we have studied at the moment, that yes, I have the logical entity tenants, these are the logical containers. We have some default tenant to manage the fabric, to manage the fabric, to manage the IPs, to manage the management, like that. So we have management tenant, we have infra that will manage the ACI fabric, we have tenant for common task, we have tenant for the management purposes as well. So by default, once you open the Epic controller, you'll find three default tenants, and that should be there because of their use case. Here in the diagram, you can see that, okay, something is coming from outside. So inside the logical entity, I have application profile. Inside that, I can define endpoint groups. Remember, endpoint groups are nothing but common task. So common endpoint related task, for example, web app DB, that can be grouped inside endpoint group. Bridge domains, from where you are getting the gateways or the subnets or the IPs. So the gateways are defined here in the bridge domain. They may be part of VRF. Yeah, that's indirect relation. So they're part of VRF. And then if you have different endpoints, say a web endpoint group and say application endpoint group, they will communicate with respect to proposals, contracts. So inside contract, I have subject and filter. In our Ansible program, we are going to create the tenant with the program. We'll create the application profile. We'll create the bridge domain. We can create the contracts as well. So for that regard, you should understand that what is the common terminologies we have inside the tenant. Again, you have the VRF mapped to the bridge domain, and VRF is like VRF, virtual routing forwarding instance, correct? In Cisco, we are using this VRF from long duration. We have bridge domain is the bound to private network, that is the VRF, represents L2 boundary which can be a span across switches, can operate in proxy, that is the default mode or traditional flood mode, limits the scope of broadcast, and the flood contains any layer 3 subnets as well. So bridge domain is also very important because whatever endpoints group you have, you are mapping towards the bridge domain to get the gateways. Then we have application profile. The logical entity inside the application profile we use to define the endpoint group, correct? So logical container for endpoint group provides a label of health monitoring. QoS can be applied on the application profile. Finally, we have one example where you can see that, okay, I can group the common tasks. So endpoint group related to VMs, related to web application, endpoint group in application related to application VMs, or maybe physical devices also, EPG in database related to EPG services. These services, because they are the different EPGs, endpoint groups, so they need contract to communicate with each other, because again by the end of day they are the stateless features. All right, then finally you can see the endpoint group. Now endpoint group, why we have this slide? Because you will find that most important object type in ACI model represent a collection of similar endpoints which will share policies like security, VM, mobility, QoS, L4, L7 services, completely decoupled from the logical and physical topology. So all important things you are seeing here in the endpoint group, they can categorize as application endpoint. See a long list: application EPG, L2 EPG, L3 EPG, management EPG, OOB inbound. Two types of EPG we have: regular or attribute based. Attribute based means suppose HR. So I have endpoint groups, they have the common name called HR. So I have 25 endpoint groups like that. It's like that. You have some common term or common name in between them. So you can have the attribute based endpoint group as well. Now again, if you go deeper on the ACI Fabric and the structure, you'll find that, okay, all these endpoint groups, they are mapped with the bridge domain, correct? So bridge domain, that means you are getting some common subnet. Web service HTTPS endpoints, they have this subnet. It's just for an example. And for HTTP endpoint, you have this subnet 10.10.10. Other is 10.10.10.11. Different endpoint, if you want to communicate, by default they will not. You need contract. Contract, you need to define subjects and the filter. Filters are nothing but the ACL entries. So here you can see contract group of subject, define a scope, global tenant AP, group of filter, unidirectional, bidirectional, that is the subject. Inside subject you can define the ACL entries. So these, suppose if you want to allow ICMP or say HTTP port 80 or HTTP port 443, so you have to create the ACL lines and you have to define who is the provider and who is the consumer. So for example, the provider is app, consumer is web. So that relation you have to create along with your ACL entries. So that was the thing that we have discussed so far. In continuing this or adding this, we have total 3 video for ACI, just that you understand ACI before doing the programming related to Ansible. And next module onwards, we have the programming related to Ansible to create various logical entities inside the ACI Fabric. Next, we have Fabric Access Policy. Before understanding Fabric Access Policy, I want to make one point clear, that in the ACI Fabric, We have leaf and a spine structure, correct? So we know that thing, that you have leaf connected with a spine. Let me change the color. Maybe it's not visible. So we have such type of a structure along with the database. So we have leaf connected with a spine, then we have leaves, then we have a spine, and they are connected like this, correct? So all the leaves, they are connected with a spine and vice versa. Now here somewhere you have the database as well, and that's the network you have. So you have the management plane as your epic controller. You have your leaf and a spine as a collapsed data and control plane. Now the important thing here is to understand that where these policies fit in. So we have fabric policy. Inside fabric policy, you will find that you have fabric policy. So I have fabric policy, and then I have fabric access policy. This one, fabric access policy. So whenever you are going to create the policies here, so maybe these leaf switches, they are connected with Nexus 9K, maybe they are connected with physical or virtual world. Here you have fabric access policy. You're creating the policy for the endpoints, correct? In between the leaf and a spine, somewhere here, you are creating the fabric policy. So I have leaf, I have a spine, in between I have policies related to fabric policy. Now since this is the hardware, so what is my, say for example, underlay for a moment. So since these guys, they are the underlay that I have, and on the top of these underlay, what I can do, that I can create multiple logical views, correct? So these are the underlay. I can think this as an underlay, and then on top of that I can create multiple logical network. Technically those are multiple virtual network. So virtual network. Now these virtual network that we are creating on top of, say, underlay. So these are the underlay, and then I have the overlay. These are nothing but in ACI they are termed as a tenant. So tenant is nothing but the virtual network. Now since the tenant is a virtual network, or the abstraction from the physical hardware in terms of logical plus the virtual network, then this tenant may represent a customer, a business unit, any logical entity. It may represent all these things. Now this tenant is nothing but the logical, but your physical configuration you have to do here. So that's why if you see the entire configuration inside the ACI, what you will find that you have something called the physical configuration. So you are creating interface profile, switch policies, global policies, etc. But somewhere you have the virtual network, or you have the logical configuration as well. Like inside tenant, you are creating application profile, then application profile, say endpoint group. Inside that you have the endpoint. Those are physically connected here. So apart from that, not only we have the application profile, but we have the bridge domains, we have the VRF, we have the contract, like the rule in between the endpoints, etc. It's like that. But you have the physical infrastructure. On top of that, you are doing the abstraction, and you are creating the logical network per customer or business unit, etc. It depends what type of logics or what type of virtual network you want. Now here if you see, and we have so many slides to make or to explain this clearly. So this is something like we used to do. So we used to log into the switch. We used to go inside the interface, say Ethernet 0/0. If it is a switch port, we are giving switch port. If it is a switch port mode access, switch port mode trunk. Those things we used to assign, correct? What VLANs they want to participate, etc. What interface policy, it has a selling policy, CDP, LSCP, LLDP, STP, and so many. Correct? So here these things are very much familiar. The only thing that we are doing in this case in the ACI is the way that we are configuring is different. The way we are configuring is something like template based. We are creating the template and then we are associating those templates for those configuration. That's the difference we have. But what is the overall scenario we have? That you have something called, say, physical devices. We are creating multiple instances, say instance A, B, C as a virtual network, virtual network, virtual network, and these underlay. So this will be the overlay on top of that. This is the underlay from where you are taking the abstraction. They are combined called as a fabric, and we are talking about ACI Fabric. Correct? So now we can debate, okay, what is the glue in between, who is connecting the underlay with the overlay? So that's why we have attachable entity policy, AEP, or sometimes accessible attachable entity profile or policies. He's the glue in between the underlay and the overlay, and then things will connect and then work. Okay, so this is actually key here we have inside the ACI. In the next section, upcoming section, we'll talk more about the theories only, but if you understand the theory that from where the traffic is coming, so suppose I have my ACI Fabric, so from which endpoint the traffic is coming, how and what is happening inside the ACI Fabric, and then how it is going outside. So either your traffic is moving inside the single fabric, or maybe you have two data center and then you have ACI this place, ACI place this. So how the data will come as a source here and destination here, how it can go. That may be use case number 2. The third use case, you may have that your source is inside, you are going outside to the cloud, or maybe you are going outside to the WAN, and then you may go somewhere to the branches, etc. So how we can go outside? So those things will be there. So within ACI, outside to the ACI, from one ACI fabric to the other ACI fabric with the DCI connects and all this traffic flow, you can understand once you understand the basics behind the scene. All right, so let's just stop here, and next section will continue from. Now let us discuss more and build the basic fundamental knowledge about the ACI. So before understanding the glue between the, say, underlay, whatever hardware I have in the underlay, and the overlay, what type of tenant and logic I have, so physical and logic, physical hardware and the virtual network, let's understand few of the things before moving further. So what I want here that let's discuss little bit about the construct of the ACI. So one side you have the tenant. So what I have my virtual network, and here I can have my VRF or context. I can have my bridge domain, is something like VLAN. Sometimes we are thinking about broad VLAN or VLAN, anycast VLAN or something like that. So VLAN is spread it across the fabric, and this having the subnets where I can define the gateways. Then we have something called, say, application profile. We have application endpoint groups. Inside application endpoint groups, we have the endpoint. Then we can have contract, and inside contract we have the subject. And then finally we have something called filter, very much similar to the access list or something. So inside the subject I can call the filter. Now this contract I can apply across or in between two different endpoint group. So maybe if I have endpoint group associated with web, and I have endpoint group, say for example associated with app, in between I can apply the contract, correct? This is again the logical network, but it is coming on the top of access policy, and if you are creating the access policy, what are the things you have to create? So you have to create the interface policy first. Inside the interface policy, you will define what is the CDP, what is the LLDP, what is the STP, what is the MCP, what is the link speed, etc. So you have so many things. We'll see. We have slides for that. Once you have the interface policy, then you can group that interface policy inside the interface policy group. That is again very important. So what is this interface policy group? I'll write on the top here, somewhere here. This interface policy group, interface say policy group, you can have, say for example, AAEP here, and then you can define that what VLAN pool. You can define that what domain, etc. Correct? So domain means sometimes in switch we can tell, okay, the switch port mode access or no switch port. Either it's a L2 or L3 domain. VLAN pool we are associating, okay, VLAN 10, VLAN 20, VLAN 30, etc. Then once you have the interface policy group, you can call that interface policy group inside interface policy profile, where you have to give the interface selector. So you are calling this, say this is for example 1, this is for example 2. Inside 3 you are calling 2, automatically it will call 1, and then finally inside number 4 we are creating the switch profile, and then everything will be attached. Correct? Remember this AEP, something that's the glue between the access policy and the tenant. Now understanding this flow, now we can move further and discuss more about this. So now at this point of time, we understand what is the end point. Endpoint is something that may be VM, that may be physical system, where you are getting the MAC address, or where you are getting the IP address, or you have some ARP request. So these things under the fabric can reach to their spine because they have maintaining the databases, the COOP databases. We'll learn more about these COOP databases and the message exchange in the upcoming section. But yeah, you have the endpoint. These endpoints are connected with the leaf. So I have the leaf, and then leaf is connected with some other third switch, maybe Catalyst 3K or something, where you have the endpoints. They are carrying the MAC or IP or the ARP. Where I have the leaf and a spine, they are learning those, means the leaf will send message, so my spine will learn those addresses, and then the exchange of the traffic or traffic communication will happen, etc. These things will happen. So I want to draw this diagram one more time just to make this little bit easier to understand. So I have leaf 1 here, and I have say endpoint 1. Then it is connected with, say for example, a spine 1, and say for example a spine 2, and then here I have, say for example, leaf 2, like this. Now we need to understand this, that if we are in the same subnet, same EPG, so whatever IP is irrelevant in ACI. Means if they are same IP address, if they are different IP address, doesn't matter, until unless they are the same EPG endpoint group or different EPG. So if they are same EPG, no contract is required. At the moment you think contract as a filter rule. So no filter rule required within the same EPG. That's the golden rule we have in the ACI. By default it is not required within the same EPG. But if you have different EPG, either with the same subnet or with the different subnet, contract required. Okay, so we have actually only 2 use cases here listed, that you have the same subnet, or if you have different subnet. If you have same EPG, the contract is not required. But if you are in different EPG, either it's the same or the different subnet, contract or the zoning rules or the filter rules require. Okay, so this is actually the key point we have, and one by one in these slides we'll understand more about these points. Before moving further, we have again this particular chart. So this is what? This is your interface policy. So your interface policy you are calling where? I'm calling inside interface policy group. Now this interface policy group, they have access entity profile or attachable access entity profile, physical domain, either it's L2 domain or L3 domain. Now what's the VLAN range, VLAN pool? You define these things. So this is something, say point number one, this is point number two. Then you can see that you have interface profile, where you have interface selector, where you calling the interface policy group. And finally, you have the switch profile. So these are the logistic we have in this flow, and we have to understand both the thing. So not only you are understanding the physical connectivity, so what is within the fabric, this is again become irrelevant. What is inside the fabric, this is one time setup. What type of rules and policy you are creating here. So now I told you this is a mix of data and control plane, this particular diagram. So we need to isolate that, okay, since you are telling that SDN is something that I am decoupling the control plane and the management plane, but you will find that since the evolution of SDN, it doesn't mean that you have only, say for example, control plane, you have only, say for example, data plane, but nowadays we have management plane also. In ACI, this is from day one. We have orchestration plane as well, so I will not go inside the orchestration plane, or maybe something, some software hosted over cloud from where I can go and configure, deploy all these private and public cloud, etc. But the control plane and data plane we have inside this, say, spine and the leaves, and the data plane is nothing but the VXLAN. So what's about the control plane? What are the control protocols we have? So we have control protocols like COOP, Council of Oracle protocol. We have ISIS. In between these leaf and spine, I have layer 3 reachability. So that's why they are doing something called equal cost multipathing type of thing. At the moment, these devices, they want to form, or they want to communicate actually from one place to other place. We'll come to know that these leaf, they are termed as a VTEP, VXLAN tunnel endpoint. They are termed as a VTEP, VXLAN tunnel endpoint. They will form the dynamic tunnel, and then the communication will happen. Now it seems like, oh, how easy is this? So you have your endpoint, and once endpoint will come to this interface, he will send the message, oh, it's fine, this is the message of this endpoint. You learn and store inside your COOP database. Because this spine is working as a route reflector, he will reflect those information to all the leaves inside the infra. Now I can't tell this that this is a type of route reflector, but you can think like BGP type of route reflector. So once the spine has the information, he will send those information to all the leaves. So this leaf also have the information of this particular endpoint, and then if they want to communicate, they will form dynamic tunnel, VXLAN tunnel. So this particular VLAN that I have here associated with this port, this will become locally significant. Why? Because this VLAN will automatically map inside the ACI. That's the feature we have. So that will be automatically mapped with the VNI, some VXLAN network interface. Here also they will map with the VNI. These are the L2 VNI, and then if it is L2 traffic, they will communicate. Again, it seems like it's a very straightforward thing that I connected the device, it is working. But what Cisco has done, that they have optimized the data plane behind the scene, plus so many optimization and tuning inside the control plane and the database learning or the endpoint database learning also over the spine. So these things has happened. So let's just stop here, and next section we'll start from here only. We'll discuss more about the policies and the contracts, because it's the same EPG, same type of subnet, so obviously we don't need contract, but we'll discuss more the basic steps in the upcoming sections. In the bare metal lab, we are going to discuss that, okay, if we have the connectivity in say normal Nexus world, how you can going to do the configuration, and when you are doing the connectivity, so from NX OS normal traditional network, if you are going inside ACI, then how you are doing the connectivity. These are the things we are going to discuss in this, and in later section, later video recording, you'll see that inside ACI how we can configure. We know this thing is very easy in the Nexus world, that you can go to the interface, you can make the switchboard, maybe mode access or switchboard trunk allowed VLAN, and you can allow whatever VLAN these endpoints or these host belongs to. So let me show you one slide I have. So for example, you have your leaf switch connected with say any blade server, for example UCS C series, where you have the hypervisor and you have your ESXi hosted. On top of that you have your virtual machines or guest operating system. So how it is in normal NXOS or traditional network, we have what switches are connected with ESXi. So for example, switch 1. What are the VLANs for my ESXi host? So for example, this is the range of the VLAN for the ESXi host. How do we send the right VLAN to right place? Then we are using the allow VLAN. Remember, all these things are related to the traditional or the Nexus OS. Then what interface configurations you have? So channel group mode active, what is the speed, what is the duplex, what is the CDP, LLDP, etc. Those configurations. Then finally, what is which interface is connected with that particular server. So this configuration we used to do from long time, but now if you convert this configuration inside ACI, then how it will be. So the first and second thing is related to what objective we have and how we can connect with Nexus OS. In the bottom you have that how you are going to do that thing inside the ACI. So inside ACI, the VLAN and the VLAN number, it will be inside VLAN pool. So I can go inside VLAN pool, I can create that object for VLAN pool. Then switchport mode trunk and the allowed VLAN, I have to create the domain. So is it L2 domain or L3 domain or any other domain like that? But those things you can create from AEP. So there the logistic is that you go to interface policy. Inside interface policy, you have to create these things. So next, what interface policy like link label, CDP, LLDP, port channel, MCP, etc. So the first step is the interface policy. Second is interface policy group. Once you are inside the interface policy group, then you can define these things. So inside that, actually you are calling interface policy. Along with interface policy, you are calling AEP. Inside AEP, I can define the domain and I can define the VLAN pool. Okay, so I can define the domain, I can define the VLAN pool. Then once you have those things, so what is the order in ACI? So first of all, what are the things you are defining? First of all, you are defining the interface policy 1. Then you are defining the interface policy group, where you have the AAEP, where you have the domain, and where you have the VLAN pool. Then third, you are defining the interface profile. Interface profile, you are calling the interface policy group. and here you have the interface selected. Once you have the interface profile, finally you have to go and create or call all those things inside the switch profile, and that's it. Your access policy related to southbound or your access policy related to endpoint will be done. Okay, so this is actually important slide. What you want to do, how you can do in Nexus, how you can do in ACI, what are the terms where it is fit in, you can have a look and correlate with. Alright, so let's stop here. Alright, let us perform the task here inside the ACI. So the lab that we have seen, the lab setup, the same type of configuration I am going to do. Whenever you are going to do the configuration, remember you have to start with, say for example, interface policy. There we have different type of interfaces and policies related to that. Then you have interface policy group where you are going to call this. But here you can define the AAP, what is the VLAN pool and what is the domain. Then you have to create the profile related to interface and related to switch. So policy and profile, these two things we have, and if you go and create this step by step, so all those options you will get automatically inside the ACI Fabric. So let me go inside the interface policy. You can see I have the policies. I can go and create a link label policy. So suppose 1 gig is my policy. Then I can go and select say 1 gig, submit this. I have one policy that is 10 gig initially created, no problem. Likewise, I can go and create say CDP policy. This is CDP policy. CDP should be on. You can see the admin state is enable. Likewise, I can go and create say LLDP policy. So LLDP policy, this is enable. The RX and TX are enable. So I have this LLDP policy. You can see that we have long list of policy like fabric channel, priority flow, slow drain, port channel, analytic, port channel member, spanning tree, storm control, MCP. We have so many policies. The good thing about the ACI is that once you create all these policy classes or policy template, then I can reuse it n number of times. So next what we have, next we have policy group, and inside this policy group, I want to create access port policy group. I'll give the name say my policy group, and inside this my policy, I can scroll down and then see you can call all those things that you have created. So for example, 1 gig. Then we have this CDP policy. Then we have this LLDP policy, whatever we have created. And if I scroll down, here you can see that we have the glue as well. What is that? The attachable entity profile. Go click there, attachable entity profile, and you can create the profile. The other option you have that you can go here to the global policies. Inside there also you can create the attachable entity profile. You can go and create the pools as well. You can go and create the physical and the external domains as well. From here also you will get all those options because all these things are linked together, correct? So I'll give the name say my AEP, and then here what's the domain, what's the VLAN, etc. So I'll go ahead and click domain, and I want to create the physical domain. Update. Now this physical domain is by default connected with this particular VLAN. So now if you want to change this, then what you can do at the moment, let me go here and let me cancel this. So what I can do here, that I can cancel this physical domain and cancel this. I do not write this rather than what I can do, that I'll remove this. submit it. I'll go in the bottom here. So for example, I can come to global policy, and inside this global policy, let me delete this first because it is associated with physical domain. Even you can edit as well, but I'm showing you that you can delete it. I can go here down to the physical domains, and physical domain, I will right click, create physical domain. I'll give the name, say my physical domain. Then I can select the VLAN pool. I'll create my, see, I have my VLAN pool. Let me show you that how we can create. So I can create my VLAN pool, and the range I will give, say, static allocation for that. The static allocation, for example, I'll give from 100 to 500. Okay, submit. So now I have the physical domain and the static VLANs binded with that. This my physical. Now I will go to the global policy. So I have my global policy, and inside this global policy, I can give the name, say my AEP, and inside this now I can go and call the domain, that is my physical update. You can see the VLAN 100 to 500, correct? And then I can click next. I can go next and I can finish it. So once I have this, then I can go to my policy group. Inside that my policy group, I can scroll it down. I have this AEP. I'll go here, I'll select my AEP, and I'll click submit. Now this VLAN, this policy group, they are calling all the policies plus my AEP. My AEP will call the physical domain with the given VLAN pool that we have created. So now you can see the logistic. Although if you do this first time, you'll find it a little bit difficult, but once you have the proper understanding that what you are doing with respect to Nexus CLI and Nexus configuration, then it makes sense. Now, what is the next thing that we need to do? We need to go and create the interface profile. So I'll go here and create the interface profile. Uh, interface profile I want to create for, say, for example, port number 29 I have. Better I'll give some better name. So this is, say, for example, leaf 101 129. I'm giving the interface profile name like this, but you can give the name like this also, 1/29. But if you give the full name, then suppose if I give this name, because naming is also very important in the ACI. So with the name also you can understand where it is. So if I give the name like this, then 1-29, I can use whatever leaves I have. If I have same type of 1/29 configuration, correct? So 1/29 and the interface is 1/29. Then I'll call this my policy. Now you can see the power of the templates or power of the objects. This my policy I can call to n number of interfaces. Click OK, submit. So now I have one leap profile, and I want to create one more, because if you see the diagram, you'll find that leaf 101 was connected with 1/29 and leaf 102 was connected with 1/21. Again, I am calling the same profile. Submit. So once I have the interface profile, then what is the final step we have to do here? I have to go inside the switch policy and then the switch profile, create the profile. Here I can give the name, say, leaf 101 129, now, because now we are referring the switch, which particular switch I want to assign that interface, correct? So first of all, that is 101. I can click here update. I can go next. Then clearly I can go and select 29 and finish. So now it makes sense that 1-29 we are selecting 1-29, correct? Like that, I can go here and 102, 121, because this time we are going to select 1/1-21 or 1/21. Here I can give port selected, and then this is something 102. I can click update, go next, and this is 1/22, finish, and now we have the proper configuration. So this is the configuration, say, related to the access policy. Next, what we have to do, we have to go here, and I want to create a new tenant. So suppose this tenant is bank ABC. Bank name is ABC. So bank ABC, one of the customer. The VRF is say bank 1. Submit. Now I can go inside that particular bank and I can create what are the things now we have to create. So now we have to create the things related to, say, application profile, endpoint group. In our case, everything is web. So I have endpoint, web related endpoint, IP say 10.10.110, and other is also say 10.10.111. Because they are in the same endpoint group, so we do not need any contact in between them. Then we'll go and define the bridge domain. Inside bridge domain, we'll see what options we have. The subnets, if you want, these guys, they have the subnet, for example, 10.1.1/24 here. And then we need to do some sort of static binding, because the overall topology that we have is we have say leaf 101, we have leaf 102, they are connected with a spine, but the endpoint is 1/29 and 1/1/21. Here I have the web endpoint. Okay, so let's stop. Let us continue where we left off. So what I want to do, I want to create application profile. I'll give name, say application profile web, and alias, description, tags, monitoring policy. Then you can say EPG, endpoint groups. Yes, this application profile have web endpoint group. What is the bridge domain I have? I can go and create bridge domain, something called VLAN, that is a spread across all the same type of endpoint group. So this is something I can give say name web bridge domain. Then here you can see the VRF I can assign. The bank 1 is the VRF. Endpoint retention policy, IGMP snooping, I will check later on. Then if you go to the next page, you can see, if I scroll a little bit up, you can see you have main page, L3 configuration, advanced troubleshooting. At the moment, they are in the same subnet, even the subnets are not required. So you can see that by default, unicast routing checked, R flooding is not checked, conf BD MAC address is checked. Subnets, in our case, actually it is not required, but if I go and click to the subnet, and here you can see that I can give this subnet because all my endpoints are in this particular segment or the subnet. Treat as a virtual IP, make this as a primary. What is the scope? Later on we'll discuss more about the scope, what is the private, public and shared scopes. We'll see those scopes. At the moment it is telling that I have one VRF called bank 1 and all the endpoints are in the same VRF. So that is check mark. That's okay for us. Let me click OK, and once I am done with this, I can go to the next section and I'll click next to finish this. So let us finish this. Now I can go and click update, Before doing the update, you can see I have the domain option. We have created my domain. Once I go and create my domain, it is asking about the what paths I have. So suppose if you don't want to give this path from here, although you can go and give the paths from here also, there's no problem. What I can do, I can cancel this. Let me cancel this first. Yes, I want to cancel. And then again, everything is cancelled. Let me do that hard work one more time. So this is AP. Why I cancel? I'll tell you later. So I have say web EPG, and then I have bridge domain. What's the bridge domain? I have, although you can see that bridge domain was there. So I'll cancel this section, that is bridge domain related section, because already we have created one object called bridge domain. I'll click update. I can submit. So now you can see that I have application profile. Inside that I have application EPG. I have web EPG, correct? So no problem up to this particular logic. Next, what I want to do here is I will go inside the networking, and here you can understand that my ACI Fabric can do L2 bridging, L3 networking. Both the options we have. And inside networking, obviously you will get the option related to bridge domain and all. So let me click here to the networking. You can see the bridge domain. I have one bridge domain. That bridge domain is a WebBD, and it is connected with a VNI. It has one multicast address. It has the MAC address. It has the hardware and all those things. So if I go and see here, you can see over the networking, I have VRF called bank, and with that VRF, my BD is connected. Okay, so now what I want actually, that I want to connect leaf 101 1/29 and leaf 102 1/21. All right, so all those things I can go to the application EPG, and you have to go here to the application EPG. Let me expand this also. If you go and click to application EPG, you can see it is asking about the domain. It is asking about the static port. So first of all, I will go here, do the right click, add the physical domain that we have created. We have created my physical, deploy immediacy is immediate, resolution is immediate. So at the moment I connect this, they will do the deployment. Then I have this static port. I can go and click a static port over the interface. This was the port, correct? And remember what was the leaf? Leaf was 101, and 101 our port was 1/29. If you have any VLAN, a specific VLAN value, you can give, say for example 100. Then deployment is immediately. Then rest of the things are okay. If you want to make this as a trunk or access untagged, you can make this as access untagged also. So one was this. What was the other port? The other port was leaf 102, and then it was 1/21. So let's go select that. And so for example, VLAN 100, and the access untagged, deployment immediacy is immediate, and click submit. And that's it. So this is the way where we have connected our logical network. So here I have the logical network. I can go here in the networking. You can see the networking. I can go here to the application EPG. You can see the application profile. So here successfully I have connected the physical with the logical network or the tenant. So this is the way that you can perform the simple bare metal type of lab task, and you can add all the pieces whatever you have in the underlay and in the overlay, in the physical environment and in the virtual network. All right, so we have completed the lab. You can see the logical representation of the lab where we have the same EPG. Inside that we have the endpoints, and then we have connected the policies like access policies and the tenant policy. The next case that we have is that we have different endpoint group. You can see that I have different endpoint group, but those endpoint groups, they are part of same IP subnet. Since I have different endpoint groups, say for example web and app, then I need contract in between them to allow the services. Now here you can see that someone can become the provider, someone can become the consumer. Consumer is something like someone is the client and client has to initiate the traffic. So suppose if this is the direction, means my app is the provider of the contract and my web is the consumer of the contract. Okay, same way we'll create it. So suppose I will create one tenant called say bank 2, and the VRF I will use say web, or maybe I'll use a application. Inside that bridge domain I will create, so here you can see that I have the same bridge domain. So bridge domain I can create say app web or web app, whatever. Then I have application profile. Inside application profile I have EPG app and EPG web. Like that I'm going to create. Same thing, everything will be the same. The steps will be identical, nothing more on that. So what I'm going to do this time, that again I'm going to use say port, say for example I'll use 30 and 22. Okay, because 29 and 21 we have used in our earlier example. So let me log into the Epic controller and then I'll show you all these steps one by one. So I logged in inside the Epic controller. What I will do, I'll go to my Fabric and then I have the access policies. Remember in last section we have created interface policy group. So the same interface policy group, that whatever I have created, I can use it. I have interface policy as well. So let me show you this interface policy. This is the interface policy. Like I have created some link level policy, some LLDP, CDP, etc. So same interface policy groups I can use. So next, what is that I need to create the profile. So I'll go here to the profile. I have you can see 21 and 29. Likewise, I can go and create two more. So I'll create, say for example, 1-22 and then the interface selector. Say this is 122, this is 1/22. Now again you can see that this makes sense, that what we are doing here. Submit. Then again I'll go here and this time I'll create with say for example 1-30. Then we have the interface selector. I can go and give the selector 1/30. I should give like this 1/30 and then 1/30 and then my policy. Okay, submit. So now I have my interface policy group, interface profile. What I will do, I'll go inside the switch and switch profile. Inside switch profile, I have leaf profile. I'm going to create two more leaf profile. One is 22. So for example, with leaf number 101, My profile is 1-30. This is the interface, and port selector, you can give any name here, no problem. The blocks, what is the block? 101. Yes, update this, and then we'll go to the next. We're going to select 30, finish. So without any contradiction, it is creating that. Then I'll go and create, say, leaf 102.1/22, and then I'll go and give the leaf selector, say leaf selector or port selector, you can give any name. Then I'll go to 102, click update, click next. Then I will select 122, finish. So now from access side, you can see how easy it is, because we have done so much of reusability of template. Then I'll go to the tenant. I have bank ABC, even those leaves, and if I have same type of network view, and if I want to create inside this, I can create. There is no problem. You can see one bridge domain, one VRF, one EPG. Or I can add tenant. So for example, this is bank 2. Then I'll give the VRF name, say for example, application. That's the VRF name. Click submit. Once I click submit, then you will see that we'll get all the logistic. So I am here inside the application profile. I'll do right click to application profile. I want to create two application EPG. So first of all, let me create the application profile. This is say application, or you can give, say for example, web and app. Then here I will add the EPG. So first of all, say web EPG. What's the domain? I'll create the domain. This name is also say web and app. VRF we have called application. I'll scroll down, I'll go next. So for example, for this particular case, I'm going to give the subnet as 10.1.1.1.254/24. Private and all those things we have already discussed. Let's move on. So I have, say, EPG, web EPG, bridge domain is web app. Click here update, and I should give the domain name as well if I created that. So I should use the domain name. So for example, my physical I can use, and then it is asking the static path. So that's the problem I have. No problem. We'll leave that domain name at the moment, and I'll go and add one more, that is, say for example, app EPG. Here you have the same bridge domain, that is the web and the app and the now you can see that web EPG, app EPG, click update and click OK. So at the moment I haven't given the domain name, that I can give later on, no problem. So here I can see that inside my web app I have application EPG called app EPG and web EPG, no problem. Then I can go and check my bridge domain. Inside my bridge domain I can see that okay, I have my web app where the subnets and all other functions are there. What I'll do here, I'll go to my app and web EPG, and inside that you can see that I have options. So I have option to add the physical domain. So I'll click here to add the physical domain, and for that I should have physical domain defined. So I can go and submit this first thing. The second thing, I'll right click here and then you have the static path. Here we have the port. So web, so for example, web is connected with leaf 101 and leaf 101 is this, correct? So VLAN I can give for example 100 here. Deployment immediacy is immediate. Done. Then here also I'll go and connect with the domain first. Domain is say my physical, immediate, submit it. And then I will go and do the static interface binding. This time this is leaf 102 1/22, correct? So I'll go here and give 1/22. This is 100, immediate, submit. Alright, so once we do up to this point, still these two different endpoint group, they will not communicate. So we should go and create the contract in between them. So how we can create that? You can see here that we have security policy. I can go and click there. You can see contract. Then you have the filters. So what I will do, first of all, I will go and create the filter. Filter is nothing but the type of access control list. This is, for example, app to web filter. What you want to add here, you can see that you have entries, name, alias, ether type, ARP, protocol, etc. Once I click plus sign here, so what's the name? So name is say app to web. Ether type, say for example IP. R flag is unspecified here, means any. Like in access list you have any to any, unspecified means any. So what IP protocol you want to use here? So for example, I want to use ICMP. So now what's the rule? The name is web app, the IP ICMP, and what's the source? Any to any. What's the destination? Any to any. So it's something like that we are giving permission for ICMP any to any. Submit. So once I have the filter, I can go to the contract. Inside the contract, you will see that we have the subject. So I'll click here to the contract. Contract name is, for example, app to web. What's the VRF? What's the scope of the VRF? Scope of the VRF, I can give say VRF wide, tenant wide, global. So at the moment, this is residing inside the application VRF. VRF name is application itself. Then here you can see it is asking about the subject. I'll go and give the subject name. The subject name is say for example app to web. Apply both direction, A to B, B to E. Reverse filter ports. Say by default these options are checked. That means you are using only one access list that is applied in two direction, in to out, out to in. Suppose if I uncheck this, that means I need to create now two access list, one from A to B and then B to A, or two filter A to B or B to A. Then I'll go and call what filter that we have created. Our filter name is something like app to web. Update this. Okay. Submit this. So now we have the contract called app to web, and who is the source and who is the destination I want to apply this filter. So in our case actually, so for example, I have web and app. So for example, I have two EPG, application EPG and web EPG. So I'll make this provider and I'll make this consumer. This is my client. And in between that, I'm going to create the contract. So for that, we have various option here. First of all, I'll go to application EPG. You can see here that application EPG, if I do right click here, see add provided contract. I can click here. Then what's the contract you have? Bank. This I can click submit. We have all the option about the contract level and subject level as well. That's the one option. And then I'll go to the web, and here I will do add consume contract, and that's done. This will work. The other option we have, so if I go to this application profile, here you can see we have the topology. So inside application profile and the web app, that is the application profile name itself, here you have this contact. What you can do, that you can click here. Now this will become the provider and this will become the consumer. And now you can fill these blanks. So who is the provider? Provider is the EPG, that is application. Who is the consumer? Consumer is the web. Correct. What's the contract name? Although we have the existing contract, so I can go and create from here. Even you can go and create from here also. Correct. So I can go and call what contract we have. We'll give this name. If you have any L4 to L7 services, you can go and use. Let's scroll down, click OK, and then you can get the relationship, and then you click submit, and things are good and working. So this is the way that is still you have the same subnet, but if you have two different endpoint groups, you need to create contract in between them.
Let's start. You can see that we have three type of notification. We have fault, event, and audit log. Now fault is something related to Fabric. Event is any bad thing happen in a network and it will trigger an event. The CLI equivalence is in Nexus is show logging log. Likewise, audit log. Audit log very much refer to who has the accountability, how long someone was there, or how long something has happened. Correct? So we have FEA, faults, events, and audit log. Now let's understand one by one all these three pieces. So first of all, the fault. A fault is very important because in ACI now everything is object oriented. Correct? So we have managed object, and inside managed object we have all the components or all the objects. Now suppose in Nexus what will happen, that if you assign certain VLAN over the trunk interface without creating that VLAN, it will not throw an error. But that's not the case in object-oriented programming, where your objects have the interrelationship, because obviously you are maintaining the database for all the objects and their connections. So what will happen in case of ACI is that suppose you haven't created the VLAN and then you are assigning the VLAN to certain interface, it will create one fault alarm. Or you can think that it will create one fault number. Now with that fault number, you can go and check what is the fault, what is the detail, and what I have to do. And that's the capability we have in the ACI Epic GUI. So here you can see that we have two type of fault object. One is the fault instance. That's something like direct fault. So you have object, and if anything will happen with that major object, they will generate the fault instance. But there may be chances that you don't have association directly with that object. So you can think like direct fault, indirect fault. Direct fault is very much fault instance, and indirect fault means the object is indirectly connected with those objects where you have the fault. So that is fall under fault delegate, where you don't have direct relationship in the object and then it is generating the fault. In that case, the fault delegate will create. It's very much like the fault instance, but this is for the indirect object. How we can verify this? Again, the verification, how you can see the faults, how you can go and take the action. Those things we will check in the GUI. But here you can see that you can go to the dashboard. Inside dashboard, you have the system tab. Once you are inside the system tab, then you can go and verify the fault.
So here you can see that you have the detailed explanation of what this fault is. Even the fault number is there. Sometimes we used to copy that fault number and search in Google as well, just to know more about that fault and what will be the solution, what will be the resolution for that fault. Correct. And then here you have the troubleshooting option as well, where you can go and check the troubleshooting option, and you can see in bottom you have the audit log as well. The good thing here is that in ACI that you will get the uh, example or resolution option as well related to that particular fault. Now obviously there is fault and you should have some retention policy. We have the fault clearing interval is 120 seconds, then the retention interval is 3600 seconds, and the soaking interval is 120 seconds. Again, if you want to learn more, understand more about epic fault, event, and system message, you can go and check this link. This is the fault management guide. Great. So now what we can do next, that we can go and learn about the rest of two topic, that is event and audit log. Now last thing about fault is that we have the option that we can acknowledge. But suppose if you acknowledge as well and that particular fault is not resolved. So it's still that Epic will go and erase that fault. So acknowledgement simply means that you know that fault is there and then you're working for it and you have done the acknowledgement. But until unless you do 100% resolution for that fault, it will keep coming. Okay, but we have the option that we can acknowledge to the fault as well. Now next we have the events and the audit log. Here you can see that for event we have object. Obviously we have different type of object related to events. Here you can see few example related to event and audit log. So event record, that is an object for event. AAA mod LR, log the report, and then the AAA session, log the report LR, an object for login and logout. So like that, you have the examples for the objects for events and audit log. Correct. Now either it's events, either it's audit log, again you can see here, or it's even the fault. Once you are in the system, you can see, although this is little bit a snapshot is not great, but here is, you can see that this is the system. Let me highlight here, this is the system, and then inside the system, if you see the second row here in the blue color, so you can see that you have the fault option here. So I'm highlighting fault, and then you can see that you have the events option here, and then you have the audit log. So that means from the system tab you can go and verify the faults, events, and audit log. Correct. Now once we are inside the events, here you can see that you have the all events, and then you can go and check the detail about the event. So event code, cause, creation date, and the description. Correct. Likewise, we can go and verify the audit log as well. So here you can see that we are inside the system, and then we can go and check the audit log. We have the ID, user, action, etc. Last piece in this section is that the health score, and we have a nice diagram related to health score. Even when you are logged in inside the Epic GUI, and inside the Epic GUI, again I'll show you in the upcoming session. So once you are inside the Epic GUI, you can see system, and if you go scroll down, you have the health score related to, say, the pod, uh, actually the node, the tenant, etc. Now health score is not a single entity, but it's the weighted measured entity. So what does it mean? Here you can see in the diagram that you have the health score, maybe health score is 80. So what does it mean that health score is 80? That means that it will check the state of fault alert, drops, health score depending the object, means if any issue, say for example, I'm checking the tenant health score. Now, any issue inside that tenant, maybe the bridge domain issue, maybe the application profile issue, maybe the endpoint group associated with that application profile issue. So whatever issues you have underlying with that particular object, and then the health score will come into the picture. That will be the aggregate, that will be the small object below that particular object, and what will be the aggregate response, or what will be the uh, outcome for small pieces inside that object. So you can see in the diagram that health score is in between 0 to 100. Health score is a measured value, it's a weighted value, and then it will go and check different interrelated object score, and then you will get the aggregator score. Correct. So again, you can see it will go and check the latency, remaining capacity, and then finally you have the value for the health score. So here you can see that you may have the value for the nodes with the health score less than 99, tenants with the health score less than 99. Say we should have 100% of health score that will be fully functioned, and it will show in the green. Still you can see that 98 is also healthy. Maybe some issue related to latency loss, or some mismatch in associating object from one place to other place. But obviously if your health score will go less than 80 or below that, then the color will start getting red. So from green it will move to the red, because red means that completely health score is not good. Correct. So again, we can go to the dashboard and verify the health score as well. So from the single dashboard, once you are inside the dashboard, once you are inside the system, you can go and check the health score. And once you are in the system, you can go and check the fault, events, and audit log. And once you have these information, then obviously you can go for the resolution inside the Fabric.
Hi there. Thanks for your enrollment. We are in 1 minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy. And if you're going to enroll my courses, you will get 95% discount every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCI data center 3.0. Those are the new uploads as well. So please go, continue your learning, take the coupon, enroll my courses, and study well. All the best.
So exactly what is happening at the time when you are deploying the ACI, at that time actually it is asking about the out of band IP addresses. So in that time, while you're doing the day zero deployment, you can go and give that IP. Obviously, if you're doing out of band management, you need some sort of extra cabling, and if you have out of band switch where rest of the network is also configured as a OOB managed devices, then you need that extra circuits or devices. Correct. Now here you can see that we have in band and we have out of band, both options we have. Although the out of band management is preferable, but nowadays in a newer release you'll find that in band management is also quite efficient. Now, for example, if you have in band and out band both
configured, obviously the preferred is in band, and then it will go and look the out of band. So the recommended one that we should have the out of band management configured. There are some documents that you can refer. Actually, there are a good amount of document that you can go and refer. So now in this lab, I'm going to show you that how you can go and do the out of band management configuration, although same place you'll find in band management configuration as well. Everything nowadays we are doing via the GUI, so it's actually easy to do the configuration with help of GUI. So for that purpose, we can go to the tenant and the management tenant. We can go to the node management address, and I can assign some static address as per the epic. So suppose if I have 3 epic controllers, I can give the number as a 3. I will show you these steps in the lab, but these are the steps here that you are seeing. We can go and select out of band. There you will find in band option as well. Then I'll go to the static node management address. I'll put the address as per my out of band management address schema, and then we can go and provide the contract. Correct. So how you can go and provide the contract for out of band management? It's actually most of the things will be already there. All the objects are already there. What we need to do, that we need to go and define that who is the who is providing the contract and who is consuming the contract. Correct. While consuming the contract, you can define the address range from where you want to access the device. Correct. So in the last line, you can see that enter the subnets which are allowed to access the epic. In this case, if you're giving 000/0, that means you are permitting all the devices, but obviously you should have a range of addresses, that those addresses you're allowing from out of band to access the epic devices or to access the ACI devices. Correct. So let me quickly log into the ACI Fabric, and let me show you all these steps one by one. Here we are in the lab. So let me quickly log into the Fabric. And once we are inside the Epic controller, what we can do, let me walk you through all these steps. So I can go to the tenant. So let me click there, tenants. Here you have the management. You can go inside the management. Once you are inside the management, so it's loading, it's a bit slow. Now once we are inside the management, what we can do, that we can go and check the node management address. So here you can see bottom you have node management address, but here you can see that uh, inside the tenant called management, you have one bridge domain, two VRFs, etc. So some configuration is there. I can go to the node management address, and then there are some pre-configuration I want to show you before doing any configuration. So here you can see that you have all in pod range. Some pre-configuration is there. I don't want to uh, do that. So what I can do, I can go and create the create node management address. And then we have the create a static node management address. Actually, I'm looking for a static node management address, and I told you earlier that here you will get the option for to create the OOB out of band management and in band management. Now the range for epic in my case is 1 to 3, and I want to do the configuration for out of band management address. Correct. Now it is asking me that what is the OOB management EPG. In my case, that's the default. And then it is asking the out of band IPv4 address and gateway. So I have my address. Let me give here 200/18, and then I have the gateway as well, 128.1. Okay. Uh, we don't have IPv6 at this point of time, so we can leave it. Submit. This will assign new management IP address to the selected nodes. Yes, I want to proceed, and then Here you can see. So 200, 1, 2, and the gateway. They are for the OOB addresses. Now this is the step number 1. Then we need to provide the contract. Now for the contract purpose, we can go and check the OOB EPG default. So what you can do from here, you can go to the top and you can search that you have the EPG here. Let me minimize this. So here we have the node management EPG. I can go inside node management EPG, and then we have this out of band EPG default. Now if we go here out of band EPG default, you can see that we have the provider. So provided OOB contract, you can go and click plus here, OOB contract. This is the common default. And then uh, we don't have the QS class here. So I can go and update this. Correct. So here you can see that the contract is default, the tenant is common, the type is OOB default. This is the provider. Then we need the consumer, and then we need to define the IP addresses who want to access the EPIC or who want to access the ACI Fabric, correct? So I need to go and configure the contract for the consumer. So for that we can go here. Here you can see that you have the external management network instance profile. If you right click here, create external management network instance profile, and then I can go and give any logical name here. So I can give the name as a access, and then here you can see that you have consume out of band contract, and then I can go and give the contract, that's the common, update this, and then here I can go and define the subnets. At the moment I'm giving 0000/0, but we understand that we can go and give those subnets which is expected to access this fabric. This 00000 means everything. So now you can see that we have the consumer, and we know that we have the provider for the contract, and then we know that we have the static node management addresses as well, correct? So this is the way that we can go and do the configuration, correct? And you can follow these steps as well that just now I have done. Alright, so this is the way that we can do the configuration for the OOB management. Same way you can use to configure the in-band management as well. Now the syslog messages are from years. We know that in Cisco routers and switches, we can have syslog. So over the screen we can watch or we can see, or we can store those information to some syslog server as well. So we can send these messages to the external server as well. And one of the popular one is the SolarWind, correct? The SolarWind, not only the syslog server, but a different type of alerts, events also we can view if we enable those. Here you can see the severity level from 0 to 7. That means we have 8. We have emergencies for system usable, alerts, critical error, warning, notification, informational, and debugging. Obviously, if you go to the debugging, that means you want to see each and every log message. And that's not required that actually you want to debug, you want at least the debugging level label syslog message. But your warning label or notification level messages will serve the purpose. Correct? So we'll understand that how we can go, how we can configure this inside ACI Fabric, because again the configuration part is easy. You have to go to the Fabric and then you have to go and create the policy for syslog. One important thing here to highlight that we have these different type of syslog messages. So we can have syslog related to audit log, events, faults, session logs, correct? Again, we are going to do the configuration, and then you'll understand that how and where you can put these values, where we'll get all these options. Here in these slides, you will see some of the important steps that I'm going to show you in the lab as well. Correct? So we have these four type of syslog messages that we can see. So what the fault will do, fault means that generic system issue, equipment alerts, configuration related faults, environment issues, network flap, etc. Then events mean link state transitions, log contract hits. Audit log mean know that who has done what at what duration, etc. Correct? Then we have the session log, means which particular session has, again, how much will go to the audit. So who has done what will go inside the audit. But again, who has the session as internal user or the REST API user, etc. etc. So broad range of syslog messages we have, starting with the device label, user label, audit log, etc. Correct? Now again, it depends upon us that what type of messages we want to see. According to that, we can go and enable those messages, and then we can watch or we can see that. Correct? How we can do the configuration, that I will show you in the lab section. Now there are some prerequisite that when you are doing this, enabling this syslog message, so you should have the, at least you should have the OOB contract or OOB management configured that we have done in the previous section. And then we can go and enable the syslog UDP 512 inside the contract. So when we have created the contract, at that time we can go and we can put, or we can allow the port UDP, that is for syslog messages. This is one of the best practice, but if you do not enable it, that will also work with the default configuration. But we can go inside the filter and then we can allow this particular port number UDP. You can go to the tenant management security policy. You can create one filter to allow the UDP 514, and then you can edit your contract in between the provider and the consumer, and then it will serve the purpose for the syslog. Again, how we are going to do the configuration related to syslog, that I am going to show you in the upcoming slides. You can refer these slides, whatever I am showing you here. Just for your reference purpose, I will upload there with the recording. And what configuration we need, let me quickly go and log into the Fabric, and inside that I will show you those configurational steps. Now there are some caveats, but again it depends that which release we are working, because in the release 4.xl file most of the caveats has been removed. It is a good practice that we can use port number 514 in case of out of band management or in case of in band management configurations. Again, you can see the point number 3 is that if you want to enable the login of the contact permit deny events and send those to the syslog server, you will have to change the facility filter for the default facility to informational. Correct? So again, we know that syslog message has 8 category, and one of the category is informational. So if you want to check the hit counts for the contract, then you need to enable the facility to the informational. Correct? You can refer this link here. Now let me stop. In this section, I'm going to cover ACI multi-site. I have created the playlist related to ACI multi-site, starting with the lab scenario, is what lab we are going to cover here, and then a little bit of theory behind the multi-site and the differences in between multi-pod and multi-site. Then you can see that complete lab steps I have covered, mostly each and everything related to multi-site and the orchestrator. So please go and complete these 15 videos. After that, you will be very good in the ACI multi-site technology. This is the lab topology we have inside this particular lab section for the multi-site.
You can see that I have two sites. One site is San Francisco, other site is New York, and with help of this MSC or MSO, that is a multi-site orchestrator or controller, I am going to create the templates. So inside the schema, I will create the template. Some of the templates may be common for both of the sites. So I will deploy the template uh, all together for n number of sites. For example, if I have, it can deploy to n number of sites. Some of the templates may be local or maybe belonging to a particular site. So in that case, I will select that template and push to site 1 or site 2. This is the overall IP schema we have, and while configuring, you'll find some of the TEP addresses as well in the lab section. Sometimes maybe this interface you'll find 5/32 or 5/36. In this lab, I'm going to use 5/32. So if you see anywhere 5/36, just ignore it. In the lab, we are going to use 5/32 as the actual interface. So this is the lab diagram we have, and we have various labs where you will see all these IPs and their TEP addresses. Let us discuss the evolution of Cisco ACI Fabric. Now here you can see in the diagram that with ACI 1.0, we have single pod. So here you can see that I have leaf spine and single pod fabric, and I have say spine and leaf and then physical virtual server with the database, that is the Epic controller. Straightforward with 1.0. Then next it came ACI 1.1, where we have geographically stretch single pod. So I can stretch across DC1 and DC2. That means I have the stretch fabric in ACI 1.1. Next, you can see in between 1.1 and 2.0, means in between the minor and the major release, we have 2.1, means ICE 2.1 integration with ACI 1.2. Now inside this integration, you can see that ICE SGT, that is the security tagging group, and the EPGs both having the same type of attributes. That means I can integrate the ACI database with the ICE database. And the SGT, the tagging group, and the endpoint groups, they behave like the same. So we have the, you can see the TrustSec and the ACI using IP-based EPG. They have integrated at this point. This is not the major change inside the DCI connectivity, means from one data center to other data center, what type of ACI nature we are using or what type of Epic controller we are using, but it was integration between the identity services and the Epic controller. Now in the ACI 2.0, I can see that multiple network pod in a single availability zone. Now this availability zone you can compare with maybe Amazon availability zone or OpenStack availability zone. Means you can see that now I have two pod 1 and n, means maybe 2 and more pods. So for example, I have pod A and pod B. These pods, they have the stretch Epic controller. That means in one side I have two Epic controller, other side I have one Epic controller. Epic controller, you think like a database. So one side you have two database, other side you have one database. This is in the stretched manner, and that's why this is ACI multi-pod fabric. So in between them, you can see that I have IP network, IPN. That means I have here maybe Nexus 7K or ASR routers. From the leaves, I am extending the control plane traffic, and they are using MPBGP EVPN as a extension of control, maybe type 2, type 5 different type of routes. But still we have same set of Epic controller, but we are extending or we are stretching the Epic controller across the data centers. Now, so you can see 1.0 and then 2.0. So single pod, multi-pod. Now inside we can see 3.0 and 3.2, and now we have 4.0 as well. So inside 3.1, you can see 3.0, you can see now we have the multiple availability zone in a single region and multi-region policy management. So here you can see that starting 3.0 we have multiple availability zones, and we have different zones that we have, and the multiple region. It's like in between the uh, 2.0 and 3.2 you can say, because starting from 3.2 now we have multiple site. So in general, if you see that what's the main difference between the multiple say site or multi-site and the multi-pod, that we can differentiate. Apart from that, nowadays we have other features as well inside the ACI, like we can create vPods. So here you can see you don't need actually the Epic controller at the remote area, but you can extend the leaf and you have the virtual pods as well. So now other features are also there, but one the main feature that we are discussing here is that the evolution of ACI Fabric from the single pod to the multi-pod to the multi-site. Now, when we are seeing the multi-site, what are the differences we have in the multi-site and the multi-pod? Now you can see that, okay, here also you have Fabric A and Fabric B, but in this case, you have different set of databases. So you are not stretching the database from one place to other place, but you have independent database that is managed via MSC, or sometimes it is referred as MSO, that is multi-site controller or multi-site orchestrator. Now what you can do, you can log into the multi-site controller or orchestrator, and from there you have different type of schema, tenants, site, etc., that you can create the policy and you can push to all the registered Epic controllers. Now here also you can see that to extend their control plane, it is using MPBGP EVPN, and it is connected from this place to this place. Apart from that, we have other features also in the cloud, like CloudSec, and how they are translating their tables from doing the lookup from one place to other place. So those things are also there. But you can see that now I have two major differences, that I have independent databases or the controllers or the Epic controllers. I have one multi-site orchestrator from where I can do the orchestration uh, to the n number of sites. I also have full availability zone, means reachability is full, and then I'm extending the control plane with help of MP BGP EVPN. All right, so this is the evolution that we have. We can stop here. Next, we'll discuss about the terminology and more specific terms related to pod and multi-pods. In this section, we are going to discuss about ACI multi-pod and multi-site and what are the differences in between them. Before that, we have some terminologies, that what does it mean by pod? Say pod is nothing but leaf and spine network sharing a common control plane, and control plane protocols are say ISIS, BGP, COOP, etc. Pod equal to network fault domain. So pod means you have one pod where you have the common database and you have the control plane protocols like ISIS, BGP, and COOP. Then I have the fabric. Fabric means a scope of an epic cluster. It can be one or more pod. So fabric means that availability zone or tenant change domain. That means I can have more than one pod in a fabric. Then we have the multi-pod scenario where I have single epic cluster. That means I have single database with multiple leaf and spine. And that's we have seen that, okay, you have two different pod or maybe n number of pod, but you are stretching your database across the pod. Now what's the key difference here? That multi-pod having the single availability zone. That's a very main difference we have, and in the diagram also we are going to see in the next slide that yeah, they have single availability zone. Single availability zone, that means suppose what will happen if your controller go down. So you don't have uh, one type of disaster recovery, or you don't have active type of, or you can say that two independent databases or two independent data center. So if one availability zone is down, that means you are unavailable. But in case of, say for example, a multi-site, so multi-fabric or multi-site, you have multiple availability zones. So suppose if one zone is not available, then still you have the availability, and that is a reason that why we can go from multi-pod to multi-site, because here you have better redundancy inside your data center. Now have a look on this ACI multi-pod. So here we can see that, okay, I have the database. Let me highlight. I have the APIC controller and I have stretched this, but the thing here that I have single availability zone. So across the DC1 or DC2 or DC1 to DCN, although I am using the control plane protocol, say MPBGP, so here you can see the forwarding control planes are ISIS scoop, and we have data plane VXLAN encapsulation, we have end-to-end policy enforcement. But the key thing here that you have a stretched epic controller, that's why you have the single availability zone. The rest of the configuration are, you will find most of the things are same in terms of configuration, but the availability zone is single. What are the other terms we have? So we have multiple ACI pods. See the definition of pod that we have just gone through. Interpod L3 network, we have this IPN network, interpod network. Each pod consists of leaf and a spine. We have the spine and we have the leaf structure managed by the single epic cluster, single management policy domain. So we have the single management policy domain. Now, if you see the difference inside this multi-pod and the multi-site, let me show you the multi-site as well. With the release of 3.0, we have the multi-site. We have the multi-site orchestrator from where I can push the policy. First of all, obviously, I need to register different sites to the MSO or MSC, and then I can push the configuration. I have option of REST API and the GUI. Now you can see that it is separated across the different availability zones, and then I have end-to-end policy enforcement. So I can use the control plane, say MPBGP EVPN. I can have the data plane encapsulation, means I can use VXLAN encapsulation. I can have end-to-end policy definition and enforcement. Separate ACI Fabric independent epic cluster. That's the key. So we have independent epic cluster, and that's why it has the advantage with the disaster recovery or with the disaster. So now I have two different brains, or you can say the database, and they have the uh, they are inside the different availability zones, correct? So that's the key we have here in this case. ACI multi-site orchestrator or ACI multi-site controller pushes across the fabric configuration to the multiple epic cluster, providing the scoping of the configuration chain. So let me log into the MSO and let me show you that how it looks like. So here I am inside the MSO. You can see the dashboard, site, schema, tenants, users, and admin. And then I can go, I have to register different type of controllers or sites that I can go and register. So for example, I have registered New York and San Francisco. Inside that I have list of epic controllers. Then I can go inside the schema. So for example, I have created one schema that is stretched across the multiple sites. Then I can create the tenants, I can push those tenants. Then I have the user control like user admin test. We have different type of user option inside that, and then we have the admin privilege. So this is the orchestrator that look like it's in between different type of sites, and from this orchestrator we can control the multi-site environment.
Let us discuss more about the multi-site. So now we have two different multi-site. We have two different cluster of epic controller that is managed via the multi-site orchestrator. Here you can see that both the site, they have different identifier.
So one side I can see that I have the VTIP IP, I have the VNID, and you can see the class ID. So VNID is nothing but the network information carried across the availability zone. Class ID is something identity information. So see, network information and identity information carried over different zones. And then I don't need multicast because I can do head-end replication for any type of bum traffic, that is broadcast, unknown unicast, and the multicast. So this is the thing that if we use multi-site, we can identify the network information and the identity information inside the packet. Apart from that, if we have the inter-site policies and if we have the EPGs that I am stretching, so in the upcoming slide I'll show you that how we can stretch. So we have actually multiple options about the EPG. Let me show you that, then I'll come back. So now here you can see in the bottom that I can use L2 stretch, that is the BD. Then I can use the L2 stretch. Then I have option like intersite bump traffic allow, L2 stretch, and intersite bump traffic allowed or not. So we have these three options in my multi-site environment, how I want to stretch my BD. So those options we have. Intersite policy is defined to the multi-site orchestrator are pushed to the respect of epic domains, and you will see this, we have the lab for that. So what I will do that inside the schema, inside the template, I'll create various templates, and then some templates may be common that I will push to the sites parallelly. Some templates are associated with certain site, so one by one I will select those templates and push those templates to a individual site. So like that we can do. End-to-end policy consistency, creation of mirrored APG is locally represented in the policy. Policy enforced at the ingress leaf node at the steady state. Now here, very important thing we have to understand that now if we are creating the policy, so here you can see in the diagram that, okay, I have EPG policy, I have the VNID and class ID local to that site. So I have the VNID and the class ID local to the site. This side also you will see that I have unique VNID and the class ID. So that means that my multi-site infrastructure, they have some sort of translation table for the local to the destination site, and that's true. So maintain a separate namespace with ID transaction perform on the leaf node. Who is doing this or who is maintaining this translation table is the leaf node. Required specific hardware on the spine to support this. Now, because this is the new type of feature that my spine, they have to maintain this table. So that's why we have requirement of new type of hardware. We'll see that what type of hardware we require. Multi-site orchestrator instruct local epic to program the translation table on spine. So yes, over the spine I have that table, and what type of new hardware we have and which release we have. New 9364C non-modular spine supports the multi-site ACI 3.1. Okay, first generation spine including this is not supported. So first generation and second generation, in second generation starting from 3.1 it is supported. Even you can go and check the data sheet for the same, that which hardware is supported and which hardware is not supported inside the multi-site. Most of the leaf hardware is supported in both the first generation and the second generation, but for the translation table and other new capabilities and features, we need to use the second generation spine switches. So per bridge domain behavior, we have layer 3 only access, we have IP mobility without bump traffic, we have layer 2 agency. In the lab itself, you will see that in the bridge domain, we have these options that I am doing a stretch bridge domain. Here you can see the IP mobility without flooding. So I have all these options, and while I'll create the schema and template, so inside the template I have this option to choose, and obviously once I have the template I can deploy those templates to the certain number of site. So if I used without this option, if I use the BD, that means I am doing the L3 across the side. If I use L2 stretch, that means IP mobility without the bump. So no layer 2 bump flooding across the side. And if I use both the option, then layer 2 bump flooding across the sides. So I have the option over the MSO that what type of delivery I am using across the site without uh, L2 bridging or one-sided or both side. Alright, so these were the specification related to multi-site. Now we have the new feature added, that is the cloud sec. So suppose if you are sending your uh, network ID and class ID over the cloud, we have that feature in the GUI itself. You'll find one tab called cloud sec. If you enable that, that means you are sending the control packets in the encrypted format. So that option is also there. Support planned for the future ACI release for FX line card, not supported in all the line cards, but again for this also we can refer the dataset that cloud sec encryption for the VXLAN traffic. It's supported inside the fabric. And then you can see here, because now we have the multi-site environment, some of the customer, they are looking to back-to-back data center connection. Now this is possible if your sites, if your data centers having less distance. So again, we can check that what is the distance limit when we are doing back-to-back DC connection. The other hybrid type of connection is also available, like two data centers are back-to-back connected, but one data center is connected with the IP network. So that option also we have, but it depends that what type of data center I have, what type of requirement I have. According to that use case, we can use these connections and the communication. So let's stop here, and in the upcoming sections we have to perform the lab task. So we'll understand more about the multi-site infrastructure. We have very important key member here inside the multi-site. We have multi-site orchestrator. With help of multi-site orchestrator or multi-site controller, we can manage various sites in the multi-site environment. Now these may be virtual machines hosted over hypervisor, or maybe physical appliances started from ACI 3.2 release. We have OOB Management connectivity to the EPIC cluster. They are deployed as a active resources. The main function of MSO are they can monitor the health state of different ACI sites. They can do the provisioning from day zero, establish EVPN control plane. They are defining and provisioning the policies for different sites and can do the day two operation. So in the lab section, you'll find that we have various stuffs related to MSO. For example, one of the key member is the schema, who has containing different type of templates. These templates I can define. Inside these templates, I can create what is the VRF, what is the application profile, EPG, bridge domain, contacts, etc. Everything I can create inside the schema, inside the template, and from the template I can select the sites, site 1, 2, 3, etc. and then I can push those policy. In MSO Word, it's like you can create the policy and then you can deploy the policy to the various sites. So that is the use we have inside MSO. So not only we have the active MSO appliances, but we can push the policy, means we can contain some policies and then we can deploy the policies as well. We have the deployment consideration. You can see that intra DC deployments, it's active, no problem. But if we are doing interconnection for the DC over the WAN, that you can see in the diagram number 2, then at that time we need to do the consideration that the latency should be less than 1 second. So round trip timer that is supported by MSO is between 500 to less than 100, 500 millisecond to less than 1 second between the MSO node. Hypervisor can be converted directly to the connected to the DC OOB network. Each MSO node has a unique routable IP. Async calls from MSO to EPIC. If possibly, deploy MSO node in separate site. That's the key here. So if possible, deploy them geographical separated location just for the high availability. Then we have discussed about the schema and the templates, and in the lab also you will find this, that how we have created the schema and the template, and then we have push or deploy those things to the various sites. Now in day 2 operation, there is other advantage we have the consistency checker. This thing also you can see in the lab, means when I create the policy and when I deploy the policy, at that time it is showing validating. So all the time it's keep validating that it is doing the inspect and validate full stack programming, MSC, epics, and then spine translation. It is validating the consistency of the local and remote inter-site EPG, BD, VRF, etc. Means whatever policies that I am creating, and while I'm deploying those policies, it keep validating those policy and the uniqueness of those policies. Next, we can see the key features between the EPIC and the MSO. So EPIC is nothing but it is doing the central point of management. It's a type of database who is used for the management, responsible for full Fabric local function like Fabric Discovery, Bring Up, policies, VMM, physical, creating different type of policy for L3 out, etc. Integrating with third-party services, maintain runtime data like VTAP address, VNID, class ID, GP, GIPO, etc. Now, on the other hand, with help of multi-site orchestrator, first of all, it is giving the complementary to the EPIC provisional and meaning is the most important point here. So inter-site tenant and network policies, that's the main use of the MSO we have. A scope of changes like granularly propagating the policy to the multiple EPIC cluster, can import, this is also very important, can import the policy and merge configuration from different EPIC cluster, end-to-end visibility and troubleshooting, no runtime data configuration repository. So it's the key feature we have inside the MSO, that is the complementary of the EPIC controller, and then it is adding some more values towards the managing multi-site infrastructure. Inside multi-site orchestrator, we have options for various type of users, like power user that can perform all the operations as an admin user. We have site and tenant manager. We have a schema manager. We have a schema manager restricted. We have user and role manager. So let me log into the MSC, that is the multi-site controller, and from there I'll show you that how you can create a user. Let me give me the username and the password, and let me try to log in here. Alright, so once I log in, you can see here we have various tabs, and inside this tab I'm going to create the user. So I will go inside the user tab, and you have this welcome page where you can see, okay, you have the new features, N9K, C9332, Spine, CloudSec, Intersite L3 Multicast, Firewall plus Load Balancer, Intersite Preferred Group, Shared L3 Out, Scheduled Backup. So all new features you can see here, and we have various links here where we can go and check the documents. So let me go here and click to the users. It is coming up. Alright, so what you can do here, you can click do not show this login, click get started. Now you can see the user prompt. Although we have dashboard, we have sites, schema, tenants, and then finally user. So let me click here, add user. So for example, I want to add one user for testing purpose. I'll give the password and then confirm the password. Alright, so first name is say test and the last name. Likewise, you can give the email address and the phone number. Account. Now I should give this account as active. Scroll down. You can see now we have the user roles, and that we have discussed that I can have a power user that has all the access like admin. So admin is also a user that will be there by default once first time you bring up the orchestrator. Then we have site and tenant manager, schema manager, then schema manager restricted, who will manage a schema that contain tenants to which a user explicitly associated. Then I have the user and the role manager, manage all user, their roles and password. So for example, what I will do here, I will use site and tenant manager and then save. Before saving, just remind that what's your username. Username is test. Because now what I want to do, I will go here and I will log out. Then I will log in with the test user. So log out, I will log in with the test user, and then we'll see what are the changes I have in the dashboard. Now it is loading. It is asking to reset your password. So I will reset the password. And let me do that. Okay, so now you can see that even in the back you can see I have the dashboard option and the tenant option. I don't have all the options. So that's the thing, that I can create user accounts, and once I create the user accounts, obviously I have the less option because this user has dashboard, sites and the tenant management option. So you can see that how easy is to create the user, and then you have this nice dashboard. From there you can manage the multi sites. Let us add the sites inside the MSC. Here you can see the topology diagram that I have site 1 called San Francisco, site 2 called New York, and here I am going to add my Epic controllers. So I have site 1 and site 2. So let me log to the MSC and add site 1 and site 2. Alright, let me log in. Once I logged in, then I can go to the sites. Here you can see I'm in sites, and then I want to add your sites. So I can go here and add the site. What is the name of the site? Say for example, San Francisco. Labels, I can leave that label. Then Epic controller URL. Now I need to add the Epic controller URL. So I have three different URLs, say Epic 1 A dot cisco.com, and let me copy this so I can copy and paste. And then you have the username and the password. We should give the site ID. So for site number 1, I am using the site ID 1. Let me add this because this Epic controller URL should be resolved. invalid epic credential for HTTPS epic 1. So let me give the correct uh, credential for epic, and let me try with the other credential. Now you can see that it is added. CloudSec encryption is not enabled. So like that, say next time if you want and add more epic controllers, you can go and edit. So yes, I want to add more. Next time I will add say epic 2 from the fabric, and then I will add one more, that is the epic 3. So let me add those also, 3 also added. Let me click save. So this is the site 1 that I have at the moment. Site 1 San Francisco, it having epic controller URL 3 epic controllers. So again I want to add one more site because we have 2 sites. The other site say is New York, and here the URL is, instead of A I am going to use say B, and then the password also I need to change. So let me use the correct password. We should give the correct site ID. This time the site ID is 2. Let me click save here, and now I can see that New York site also being added. Let me add 2 more URL to the site B, and this is say epic 2 and B, and then let me add one more, that is say epic 3 and B. So yeah, here it is. So we have successfully added. If everything is correct, it will resolve it properly, and on the top you can see that San Francisco has been successfully connected, New York has been successfully connected. So now we have successfully added the sites. We can stop here. Now we are inside the day 0 infrastructure configuration. What are the things that we can do from the MSC? We can do the spine interface configuration like interface selection, IP addresses, MTU setting, the control ETIP configuration used for BGP EVPN peering between the sites, unicast data ETIP configuration, multicast data ETIP configuration, OSPF configuration between spine and the IP network, BGP AS number assignment, BGP community configuration, and the L3 outs. But there are certain configurations that we have to do from the EPIC controller. So what are the things that we can do from the EPIC controller? The configuration of the access policy for the L3 domain. So next we are going to do this configuration of L3 domain, spine switch profile, interface policy group, attachable entity profile, that is the AEP, external L3 domain, BGP route reflection. Now the MSC will read in the BGP ASN and the external L3 domain from each site, add these to the each site from the respective epic. Important thing here that we need to add the L3 domain, external L3 domain, and the route reflector from the epic controller. So I'll go log into both the site epic controller, and I'm going to configure route reflector and the external L3 domain. So let me log into the first site and the epic controller. I logged in inside the San Francisco epic controller 1. I want to configure the route reflection. So for that I can go to the system, and then we have the system settings. Once I am inside the system setting, you can see I have BGP route reflector. I'll give the autonomous system say 65001, and let's see that what are the other things that we have that I can add here. Route reflector nodes. So if I click here route reflector nodes, this is a spine node 1, Means by default it is selected, so no need to change anything. And let me cancel this. Alright, so we are very much good with this particular setting. Let me submit the changes. Then next I want to create L3 domain. So for that I will go to the Fabric. We have the Fabric policy and the access policy. Inside access policy, I want to go inside the physical domain. So we have the physical external domain where I have the router domain. Once I'm inside the router domain, I can go and create layer 3 domain. You can see I have the option to create layer 3 domain. I'll give the name as a say multi-site external routed domain, and the same thing I will do to the other side Epic controller as well. Let me click submit. So here you can see that I haven't used any of the VLAN pool or other stuffs. So we are good at the moment. Let me close here. Now I'm going to log into the other side Epic controller, that is the New York. So let me log into that. So let me log into the New York side Epic controller, and you can see here that I am running the version 4.0.1h. Here also I will go to the system and the system settings. We have the route reflector. I will give the route reflector ID, that is the 65002. Submit. Next I have the Fabric and the access policies that we have created for the L3 domain or the external domain. So we have external router domain here, and I can go and create the layer 3 domain, and we are done. So this is the way that inside the Epic A and Epic B, that both the sides I can go and create the route reflector client and then the L3 routed domains. This section we are going to do the infra configuration. Go and click to the infra. Here you can see I can go to the site and click infra. Then I can see I have San Francisco and the New York. I can go and select San Francisco. Once you select that, now you can see you have three options. You are inside the site. This is the site view. Then you can click to the pod. This is the pod view, and then you can click to the spine 1 and spine 2. So I have one site called San Francisco where I have one pod called pod 1, and then I have two spine 1 and 2. So we can start with a spine or we can start with a pod also, no problem. I can go again, I'll show you. Inside a spine I can go and click this add port. Inside add port, say port is 5/32. Then the IP address, whatever schema of IP I have, that is 10.1.1/31. MTU I can use inherit. Then this MSC OSPF policy is nothing but OSPF point-to-point network policy. I can click save and I can use this IP for the future reference. So now you can see that I have added the port here, and if I click BGP peering, what is the BGP EVPN router ID? So I can go and give that also. That is 110.100.1. So that's okay. Now I'll go to spine number 2. In the same side, the port number is the same for all the places. Now the IP address, instead of say 10.1.0.1, I can give, say for example, 3 as the IP. MTU I can inherit. Same OSPF policy, yeah. And then BGP peering, what is the BGP EVPN router ID? So that I will give, say, 10.100.2. Alright, so now we have successfully configured the inside port 1, spine 1 and spine 2. And then if you see the differences in the IP, so 10.1.0.1, 10.100.1 is for BGP EVPN router ID, and then you can see the difference in the IP. Alright, so once I have done this configuration, then I'll click pod. I will give what is the overlay unicast TEP, that is 10.1.100.100, that is for unicast. And then I'll go and click the site. So inside the site is ACI multicast enable. No, I will go and enable it. Epic site is one, that's okay. Overlay multicast tip, I will give that also. So I'll make this enable, and here I'll give the multicast TEP address, that is say 10.1.100. Say for example 200. What is the BGP autonomous system? That for this particular site, that is 65001. Let me scroll down. OSPF area ID, I will use 0. OSPF area type, I want to use regular. Let me scroll down. So now I can see that, okay, OSPF policy is this, that is network type is point to point. Common default, that is okay. And if I click here add policy, so I can give the policy as well, and I can use these policies that already have OSPF having. So everything is set. I need to set this external router domain as well. So if I click here to the drop down menu, remember this we have created inside Epic 1, that I can select. So now with this particular site, I have enabled the multicast TEP. The BGP AS we have given, the area is 0, regular, and the policies, everything is done. So we have done the configuration with one of the site called San Francisco. I'll go to the New York next and the New York. The same thing I'm going to do. So let us add the port first. That port is nothing but 32. What's the IP address we have with the spine number 1? So that is everything replaced by 2. So instead of 10.1, I have 10.2. So like that we are going to use. And what's the MTU inherit OSPF policy, like the same. Then BGP peering on, what is the BGP EVPN router ID? That is 10 to say 100.1. Correct. Rest all the things are okay. Then I'll go here. I'll add the port one more time. 32, and address is say 10.2.0.3/31. MTU I will inherit OSPF policy is the same. And then BGP peering is on. What is the BGP EVPN router ID? That is 10 to 100.2. So one side, that is the San Francisco, we have the IP subnet ranging 10.1. Other side it is 10.2. Alright, so we have done the configuration at the spine level. Now I want to configure the pod level. What is the TEP address I am using here? Again, that will be 10 to 100.100. Then finally, I have to go and configure the site level configuration. So multicast enable, yes. This is Epic with site number 2. What is the multicast TEP? That is say 10.200.200. Let me quickly confirm with the unicast TEP. That is 10 to 100.100, and then the site 10 to, yeah. So that's correct. Then I should give the autonomous system, this is 65002 that we are using. Then let me scroll down. OSPF area 0, the OSPF area type is regular, the external router domain is this that we have created, then the OSPF policy, those are the OSPF policy. So now we are very good with the policies that we have created for these sites. I'll go and click deploy. Now if any problem is there, it will throw an error, but we got configuration updated successful. So now successfully we have configured both the sites, and you can see the spine level configuration, pod level configuration, and the site level configuration. All these configurations actually are very easy. So I have selected both the site 1 and 2, and I have done this configuration. So let me go here, and then again I can go to the site. So I can go to the site 1 and 2 just to check the sites and the related configurations. Configure infra San Francisco. Now we can see this BGP peering on, BGP peering on, BGP peering on. All my configurations are up, running, and saved. So this is the way we are doing the configuration. Rest of the configuration we'll do in the next recording. Let us continue with the configuration that we have done in the last section. So now I can go to my Epic 1 site A, that is San Francisco, and inside my tenant that is say infra, I can go to policies and I want to check the protocol. Inside protocol I have Fabric external connection policy. If I go and click here, I can see that I have one policy, Fabric external connection policy, and let me give the community first, or let's just scroll down. Let's see. So I have the multicast unicast data plane TEP. Let me scroll down. You can see the data plane unicast TEP and multicast TEP, etc. Now if I go here and say if I delete this, okay, so once I delete this, because this is the site related to my San Francisco, again I can go and deploy once more time. Configuration updated successfully, and if I come back, you can see we have the policy. So my orchestrator, I am going and putting these policies, no problem, because that is saved there inside the orchestrator. Let me put the community just for example, the same that is there in the example I have used there. Then I want to give the TEP data plane, so I'll go here and I will assign the data plane TEP address. Let me give that, because this is site number 1, so everything I'm using 10.1, means starting with 10.1. Close it, and let me scroll down if everything is okay. So I can see here that I have pod 1, pod connection profile, data plane TEP 10.1, multicast 10.1 100. Then the site 2, the data plane unicast TEP 10.2, and the multicast 10.2 100. So that's okay. Let me click submit. If everything is okay, it will get submitted. Alright, next what I will do, I will go back up here, and inside the infra itself I want to check my multi-site. So let me go and go inside say networking, external routed network, and I can see intersite. So if I click here to enter site, if I go inside the network, I can see that I have this new icon. Oops. Let me click up. Let me scroll up. And here in the network, I can see my enter site instance, and here it is. Let me scroll down to see more about this. So I can see the L3 out here configured. PC tags are there. Let me go back to the enter site and let's see the node profiles are there. So I have node 103. I can see the router ID, the peer addresses. I can go here, and here also I can see the nodes. Alright, so we can check and verify all these things. Then I have the policy. I can go and check the policy as well. You can see the policy VRF overlay. External routed domain. I can expand this. We have the multi-site external routed domain. Close this. Then we can go and verify each and everything, but you can see that moreover we have the OSPF BGP and all these things defined here. OSPF in regular area, and these things are there. Now if I go here and click networking, inside networking I can see my overlay and I can see my L3 and my bridge domain. So all these things are good. Now let me quickly go to the other site. Other site is the New York, and here also I will give the TCP address, that is 10 to 200 slash 32. It's a bit slow. Update. Let me click update. Let me click close. And we are done with this particular site as well. Then again we'll go and we'll verify our external routed domain. Let me check the community as well once, and then we'll go and verify the external routed domain. So let me put the community, the same thing that we have done in the other site. Submit. Once I submitted, once everything is successful, then I'll go back to the tenant, and then we have the networking. So here I am inside the networking. We can shrink this first. Then I can go to tenant, networking. Then I have external routed network. Then I can go to intersite. Before that I can go and click here to the networking. So you can see the same sort of output we have here. Then I can go to the intersite, and inside intersite I just wanted to see that my policy, that is the L3 route, is working there or not. So if I scroll down, you can see the overlay VRF, and we have external routed domain that is up and running. So this is the way that we can configure our multi-site, and we can add the site, and we can add various parameters inside the sites. This section I'm going to show that how you can create the tenant. So you can go to the tenants from your MSC and click add tenant. The name I will give, say for example, test. This is for testing purpose. Now here associated sites. So sites I can use, say for example, San Francisco and New York, and then the users, local admin, then the consistency checker schedule setting, yes, disable scheduler. I can click save, and now what I can do here, that I can go and check to the Epic controllers that the tenant name test has been created or not. Okay, so let me go and log to the Epic controllers. I'm inside the Epic controller, and if I go inside the tenant, I can see test has been created. I can go and check new test icon. This has been created from the multi-site. It is recommended to only make changes from multi-site. Please review the document. If you want, you can go and review the document. So now we have the test tenant and all these things that is related to the normal Epic. All options we have here as well. Likewise, if I go to my Epic number 1, that is the San Francisco, there also if you go and check, you can see that I have the tenant whose health score is 100%. I have the new icon. It is showing that it has been created from the multi-site controller or MSO as well. And then we have the application profile, networking contracts, etc. everything. So this is the nice and easy way that we can go and create the tenants. So we can stop now. We are going to configure intra-tenant and intra-VRF, how we can do in the multi-site environment. Now in this case, say the tenant and VRF objects will be stretched across the site, but BD, subnet, EPGs, they are local to the site. So what does it mean? That you have some objects who is globally defined, but still you have some objects, those are local to the site, correct? So here you can see that my test and the VRF, they have stretched, but my web BD, the subnets, the EPGs, they are locally defined. So in San Francisco, I have EPG called say web, and in New York, I have EPG called application, and then I'm going to work around this. Obviously, we are going to create everything from the MSC, from my multi-site orchestrator, and then I will push this configuration or deploy this configuration to the various sites. Schema, now for this I need to create the schema. So what is the schema? Schema is nothing but contain template for tenant object configuration. So a schema contain template. The template are associated to one or more sites and are used to define the objects that will be a stretch between the site. Alright, so let me log to the MSC and let us do all these things one by one. So I am here, and from this dashboard I can go to schema. Once I'm inside the schema, you can see that I have option to add the schema. Now here you can see that I have this template option, I have the sites option, I have a template, I can add the template. By default we have this template, that is template 1. Now inside template 1, to build your schema, please click here to select a tenant. So this template number 1, I can edit this template name, and I can give this name as a say common for my SF and my New York, say for example. Now here I need to click, and then you can see that various parameters that we have inside the ACI, like application profile, application EPG, contract, VRF, etc. So once I start creating the template, I'll get all those options one by one. So let me click here, build your schema, and then select the tenant. What is your tenant? Is the test. Once I select the test, here I have option to import as well. So import San Francisco, New York. Then I have multiple options, correct? So I can go and edit this application profile, add that EPGs and all those options I have. Even I can click and I can cancel as well. So before moving further, what I will do, I will name this schema as well. Let me change the name this as a, say, this is L3 stretched and schema. So for example, all right, we have this auto save option. Now inside that I have a template called common for SF and NY. Then I'll go and add one by one all those things. So already I'm inside the tenant. I want to add the VRF. So for example, I'll give this display name as a VRF1. So this is my VRF1. L3 multicast, prefer EPC group and external relationship, local relationship. We have all those options. Like we have these things in the normal ACI controller, but here even you can see that it's very easy and straightforward. I can easily go and define the objects. So once I define this particular object, that is the VRF inside my tenant, then I can go and deploy as well. So suppose these configurations I want to deploy. See, I have this option deploy sites. I can easily go and deploy to the sites. So what are the sites I have? Let me go and add the sites. So say for example New York and San Francisco. What is the template name? Common for SF and NY. Yes, save. Now once I save this, means it is still with me. I need to click here to deploy. Once I deploy, say VRF, you want to deploy? Yes, I want to deploy. Now they are pushing from my orchestrator to the sites. So now if I go there and if I check, I will find that these templates has been deployed. Changes when the template had not been deployed to the site. Okay, we'll wait till it got deployed. Now we are getting the successful message and now everything become green. Template is unverified, successfully deployed. So this template is showing the consistency for this template is unverified. Let me click. Consistency verification has been triggered. Verification fail. What is this verification? So you can see consistency verification is triggered and should have consistency between them, otherwise they will fail and then it will not deploy to the sites. So let's see, I'll go here and open in Epic user interface for New York and let me go and log into the Epics and check why it is not pushing these templates. So if I go and log into the Epic controllers individually, say for example New York and the San Francisco, I can see that I have one VRF. Let me go inside that VRF and let me see. Yeah. So VRF has been pushed. See, VRF1 has been pushed here and here also it has been pushed. So it's okay. This has been pushed. Let us go back to the controller. And now I can see after few moments it is verified. So it's okay. Now next what I will do that I want to create a specific template for a site. So for example, I want to create template only for San Francisco. So I'll give name San Francisco only template. And then I will go and add first of all my tenant, that is test. Inside San Francisco, what I want to do, I want to create the application profile. So for example, the application profile is web and app. And then I want to create EPG as well and the bridge domain as well. So let me go and create the application profile. The name of application profile I want to give. So let me change that. from here I can go and change the name. So display name is, say for example, web and app. Then inside that I can create add EPG. Inside the San Francisco, my EPG name is, say, web, for example. Then I can define the gateway subnet. You can see all these options I have, but we'll do a step by step. Generally, what is the order when we are doing this configuration? That inside the tenant, so you have tenant, you can go and define, say, application profile, endpoint group. Here you have endpoint. Then you have, say, bridge domain, where you can define the subnets. Your EPGs will refer these subnets. Your application, your bridge domain will refer the VRF, like that. So this is the logical order. But if you know the objects, you can connect anytime from anywhere. We have that option that we can connect. So for example, what I have done, that I have created the EPG, and I have created the application profile and the EPG. Then I will scroll down where I have the bridge domain. I will add this bridge domain. See, name of this bridge domain is, say, for example, web BD VRF. Yes, it should associate with the VRF, otherwise it will not work. Now I want to uncheck this as L2 stretch, because I don't want to stretch the L2. Any existing local site BD will be removed. This operation will restrict the optimize WAN bandwidth option. If optimize WAN bandwidth is changing, there will be temporary loss of traffic. Yes. So you can see I have removed that. L2 unknown unicast is proxy. Great. So now we have created the application profile, the endpoint group, and then I have my BD. So what I can do now, that it is auto saved, this has been saved. I can select the sites and then I can deploy it. So this is for the site, that is San Francisco. I'm going to deploy this to a site San Francisco. So let me go and add the sites where you want to add. I want to add here my new template, that is for SF. Click save, and once I click deploy the site, so EPG web is not associated to a valid BD. I should go here because you can see the red mark also, and that's very important. Now in this EPG, you can see that I should give the bridge domain. So we can see that not only this is doing the configuration like it is doing in the Epic, but in the orchestrator also they should know what is the logical references for all the sites. So now you can see that I'm going to apply all these things where San Francisco will create application profile, will create EPG, will have the reference of web bridge domain, deploy. Now if anything is there, it will throw an error and we can check that error. At the moment it is telling it is unverified, cannot verify as template SF, only deploy more than one site. It's okay, we'll wait till this error message will go, and parallelly I will go and log to the Epic controller and see that this is deployed or not. So I come back here and I have my tenant. Inside this tenant, if I go to application profile, now you can see web and app. Then I have web. Likewise, I can scroll down. Let me make some more space here. So likewise, I can scroll down and you can go and check the networking and the bridge domain as well. So now you can see that my bridge domain is associated with the VRF. So I have the bridge domain as well. Here is the bridge domain. This particular bridge domain having the VXLAN IDs associated as well. So I can see bridge domain, the segment, the multicast address, the MAC address, all those things I can go and verify. So if I go here in the policies, I can go and check the policies as well. So it is connected VRF1, the unknown unicast hardware proxy, where we have that option, endpoint data plane learning, the limit the endpoint. So those default options are there. That's great. We can stop here at the moment, and in the next video we'll continue from here. Alright, so let's continue where we have left in the last section. So we are doing the simple task that we used to do in the ACI Fabric, that I have created one tenant. Now this tenant called test. Inside that we have VRF, say VRF1. Then because I have two sites, say site 1 and site 2, let me draw it properly. Site 1 and site 2, one is the SF and one is the New York. So I have say site 1 and I have site number 2, NYSF. In these places I'm going to create, or I have created in site 1, say for example application profile and web EPG. Here I have created one BD as well, BD called web, and I need to define subnet. I will define the subnet. This is again map with the VRF1 that we have created, and everything is inside the stretched tenant, stretch L3. That's why we have L3 stretched schema. So here also I will go and create, say, application profile. Application profile name we will give the same like web and app, like that we'll give. Then here I have one EPG. Here I'll give name of EPG like app, and then here also I'll create the say bridge domain name application, and then I'll define the subnets. They are mapped with the VRF, they are inside the same tenant, etc. So all those things we are going to do almost the same thing that I have here, the same thing here, only the subnet IPs will change. So here the subnet is, say for example 10.1.1.254/24. Here I will use say 10.1.2.254/24. So once you create EPG called web and then EPG called app, you need contract. So later we are going to define the contract in between them so they can do the communication. So let us go back and first of all complete the task that we have done. So for example SF, I need to go here and I need to add the subnet. So I'll go inside the bridge domain. Inside bridge domain, if I scroll down, you can see I have the subnet option here. What is the gateway IP? That is say 10.1.1.254/24. This is private to VRF. Yes. So okay. Now once you've done this, then you need to deploy this to the site. Yes, you can see now one edit I have successfully deployed. Likewise, I will go and create one more template. So let me go and create one more. This time the template name is, so let me give the name of the template. This template is for New York, so NY, say only template, because the same things we are going to do here now. So what's the tenant? That is the test. Now what's the application profile name I have? The application profile name, I am going to use the same one that we have. So I'll use the same name, say web and app. Then EPG I want to add. What's the EPG? This time EPG is say app EPG. All right. Then the subnet it will ask, but this subnet I will add inside the bridge domain. So here it is asking about the bridge domain. I haven't created the bridge domain where I can call this, so I can go and type to search or create. So I want to create one.
say for app bridge domain. Yes, create it. Then once it is done, I have an option of contracts and other things also. Leave those things. I should add the VRF as well. So VRF is VRF1, or I should get okay, because this is the other side, so I'm not getting the option for the VRF. But generally what is happening in the Epic controllers, once you create the object, you can call those objects. So now I have this app BD created here, and what I want to add, say I want to add this VRF, that is common, that's correct. And now if I click here, that is also okay. So see, it's very straightforward that how we are going to do all these things. If we know what is the object, how we have to call the objects inside the other object, it's very straightforward that we used to do in the Epic controllers. Now once I do up to this point inside the BD, I need to add the subnet as well. I want to disable this L2 stretch because it's a L3 mode that we are using. The learning of the packets inside the BD is the hardware proxy. So I leave this as a hardware proxy. So what I want to do here in the bridge domain, that I want to add the subnet. So let me first save this. It is saved, and let me go back to my bridge domain because I want to add the subnet here. And what options I have? Yes, I want this common. That's okay. All right, so let me do one thing. Let me go to the EPG that is showing connected now, and here I have the subnet. What's the subnet we have? The subnet for this site we have set 10.1.2.254/24. Description I can leave it at the moment, private to VRF, yes, and we are very much good with this. So I think we have done all the required steps. I can go on the top, I can click save. Now I want to deploy this. So for that you need to go and select the site, which site you want to deploy. I want to deploy here in the New York site, that is the NY template only. Save it, deploy it. So application profile EPG BD VRF, yes. Bad because VRF is already deployed to a stretch schema template to the new site. Okay, so I will correct that and then we will deploy it properly. So this is policy has been added to the template. This VRF need to be corrected, then it will deploy. So now it is throwing that error that this VRF that we are deploying here, it is already called inside one of the schema, that is this one. So what I will do in the New York where I have the VRF, I'll go and edit this VRF option, and this VRF, so let me add this VRF, I need to change. So let me cancel this, and let me cancel this VRF because I want to add the VRF that is called. So I can give VRF1 and then let me save this. I think L3 stretch schema has been saved. Now it is okay. I can go here and then scroll up, deploy the site. Let's see. All right. So let's go and check the VRF one more time. So let's go and check all these things. So you can see the EPG, app EPG is correct, no problem. Then I'll go to the VRF. We have created VRF1. Then I'll go here to the bridge domain, and inside the bridge domain, VRF1, this I want to filter out. So what I will do here, let me quickly edit this policy. Let me go here and check that BD. So we'll go here and click here to the BD. What is the reference? L3NY. Yeah, this is the reference. Let me save it. Then I'll come back here and then I will go scroll up, deploy the sites. Yes. All right. So what I can do now that it is already deployed, and next time it is not telling me to deploy it. Let me remove this and then app BD. So these minor things we need to take care while we are doing the deployment, and it's still because we are doing everything from the GUI mode, so it will not throw that much error. So now you can see that it is corrected 100%. It is done. Now what I will do quickly, I will log into the NY Epic and then we'll check. So here I am inside the NY Epic controller. Let's go there and let's verify it. So we are here in the tenant, and inside the tenant I can go inside the test, although we can see that we have all the objects. So APG, bridge domains, etc. is there. I can go to the application profile. You can see the application profile here. Then I can go to the networking. You can see the bridge domain. Then I can go to the VRF. You can see the VRF1. Seems everything is good and working. Let's stop here. In the next section, we'll start creating the contract, because different APGs needs contract to communicate. In this section, we are going to create the contract and then we are going to apply those contracts. So I'll go to my schema. Inside the schema, first of all, I will go to my common template that I have. Inside my common template, I will go and create the contract. So how we are doing, we are creating the contract. So for example, one contract is there. Let me delete it, and what I will do, I'll show you one by one all those things. So I will go and add a template here, contract here. The contract name is, say for example, web to app. The scope is VRF, the direction is both. Here I want to add one filter for this. So I will use any to any, say any to any. That's the name of my new filter. I will save this, and once I scroll down and go to the filter, you can see I have any to any. Let me remove the old one. Yes, I don't want to use any. I have this any to any, and this particular filter I want to add a entry. Entry is just like an ACL entry. So any to any from, say, web to app, like that. I can give any name, and rest of the thing I can leave this as default. But yeah, if it is a ICMP, then I can go and give any to any ICMP. If it is HTTP, I can give HTTP, like that. I can go and specify. So if it is ICMP, I can use IP. Then I can leave this ARP IP protocol. I can go and use ICMP. Match only parameter fragments, stateful, rest normal networking things, correct? Save this. So once I save this, that means I have my template here. I have my, inside my template, I have my contract. I want to deploy to the sites. Yes, I want to deploy it. So here you can see that filter any to any, contract, web to app, and this is not the contract. So let me once verify, so this is my contract. Let me quickly verify that is 100% okay. And then what is my filter? That is any to any, that's 100% correct. And inside that entry is any to any from IP. So that's 100% correct. That means it's correct. Let me click here. Let me deploy this. Successfully deployed. Now what I have to do, I have to provide this and consume it. So I will go here to the SF only template. Here I will go to my web EPG. Web EPG, I will go to the contract inside my web EPG. So here inside that, I will call the contract like web to app. Then suppose this is the consumer. I will save this. So my web is the consumer. And next what I will do, I will go to the next template. That is the NY template. Here I will go to the app EPG. And this I will scroll down and I will come to the contract. This contract that we have created, this will be the provider. So he will provide that. So NY with the app EPG, he will provide. SF with the web, it will consume it. Correct? So now I can go and click to the deploy sites. We have done the edit for the EPGs inside the app EPG, inside the web and app, that is the common one. I can click deploy. Now if everything is okay, deployed properly, then we can go and check. So here is still it having some issue. Let me go and check why this error. Change made in the template have not deployed to the site. So let me try and deploy this one more time. Just for one site, that is the San Francisco, successfully deployed. Now it is deployed. So now you can see all green. Let's go and log to the Epic, and from there we'll see that it has been deployed or not. So I logged in inside, for example, New York, and then I will go to my tenant, that is the test. I can go to my application profile. Here you can see that application EPC bridge domain, all these things are there. If I go to my application profile, let me go to the contract. So I can show you the contract as well. I have web to app contract, that's correct. I'll go to my networking. Networking is working properly. I can go to my application profile and web to app, two EPCs, contract relationship. I can go and check the topology, and I can see that I have the contract in place, and this contract that we have here, we can clearly see that contract. Let me scroll down so we can see that. Now you can see that contract is applied properly. So app, he is the provider, and web, who is the consumer. We can see the relationship here. Yeah, so this is the way that we can go and apply from my controller, and then I can go and verify from both of my Epic controllers. So the other Epic controller also I can go and verify the same, because we have applied that contract for both the Epic controllers. So here also if I go and verify, so here also I will found the same thing. So let me quickly go and show you this inside the tenants, and inside the tenant, if I go to my application profile, web to app EPG, and then if I go inside the topology, you can see here. All right, so this was the verification. Let's just stop here. In this section, I'm going to show you that how you can configure shared services. The same that we have done earlier, that is the layer 3 only communication across sites and VRF. Now in this case, I have my two sites, San Francisco and New York. The VRF is here you can see now I am going to use VRF2, but inside the same tenant. From the other side, that is the New York, I have the shared service, say for example DNS. So I have shared VRF, I have shared BD, and since I have two different EPGs, say web and DNS, then in between that I will create one contract. So contract, you can see that is web to DNS, and then we are going to do same type of stuffs that we have done earlier. Let me go to the orchestrator. Inside the orchestrator, I can go to SF, and from here what I want to do, I want to create one VRF called say VRF2, because initially we have the VRF that is the VRF1. So here I have VRF2, and then inside that I want to create one bridge domain as well. So my bridge domain is WebDB. If I go and click here, this bridge domain is associated with VRF1. So let me go here and associate with VRF2. Alright, so once we do that, then let me go and save this configuration. And then even I can go and deploy this configuration to the SF. Alright, so now it has been deployed successfully. Next I will go to the New York, and here also I have to create the VRFs. So let me scroll down, because this time we have one shared VRF. So I'll give the name as a shared VRF. So I have shared VRF here. So I have shared VRF, and then I'll go and create one shared bridge domain as well. So let me create one, that is the shared bridge domain. Now this shared bridge domain, I will use the shared VRF. Now I have option L2 stretch, yes. Intersite bump, optimize WAN bandwidth. Okay, so all these options I'm going to use because this is the shared one. And if I scroll down here, I have the subnet option. I will give the subnet IP for this shared VRF, that is 254/24. Scope private to VRF, advertise externally, shared between VRF, yes. So I want to change the scope here, that is private to VRF and shared between the VRF. So that's great. Now what I want here, I want to create the endpoint group, that is the service I have. That service is, say for example, DNS or DNS, and then I will give the subnet. Subnet for is the same, 10.1.254/24. Now here you can see that I have option shared between VRF, and I don't want default SVI gateway. So no default SVI gateway. So that's the thing that we are doing here, that we are sharing this between the VRF, and I don't want any default SVI gateway. Alright, let me scroll down, because here I need to associate with the bridge domain, and bridge domain I have shared bridge domain. Then later on we have to create the contracts as well. I will create and apply the contracts. So we are very much done with this particular section related to EPG. Now the final task I have is to create the contract. I'll create the contract name. I will give, say for example, web to DNS. That's the name of my contract. And what's the scope? I can give a scope as a global or tenant, because this is a shared service. Apply both direction. Yeah, my ACL can go in to out and out to in. That's okay. Then what filter I want?
So I can go and add the filter. Last time we have created one filter that is any to any. So I can use that, save it. We don't have any service graph, so we can leave it. So now we are done with all the necessary steps that we have here. So now I have the application profile and I have the contract, I have the VRF, I have the bridge domain, filter I have used from the earlier. Even if I want, I can create the filter here and I can call this filter also. So that option I have always. So let me do that. I'll create one filter. I will give the name, say any, and inside the entry I'll give the name any, and everything is default. So save this, and then I can go up where I have created the contract. So inside this contract I can close this, and then I can add the filter, and whatever just now I have created I will give that. So now we have everything. What I want to do, that I want to make this this particular EPG as a provider. So for that I'll go to the application profile and EPG, and here you can see that if I scroll down I have this contract. I will go and click to the contract. It is the workflow is the same that we have in the normal ACI. What is the name? Web2DNS. Okay, and this particular person, that is the EPG, is the provider. So he is providing. Okay, so once I do up to this point, that means I have to go to the SF, and inside the SF I should go inside the web EPG, because now he has to consume that. So now if I go here and if I click the contract, what is the contract? That is Web2DNS, and he has to consume. So now we have done all these required steps related to our configuration. Let me save this, and then I want to deploy it. See, you have the yellow mark, change made to the template not deployed to the site. So we have done over the orchestrator, but we haven't deployed it to the SF. So let's do this. Let's deploy this. Here also I will go to the NY and I will deploy this. These are the changes you can see, and let me deploy. So now we have successfully deployed this configuration. Now what I will do, I'll go to these sites individually and verify that it has been pushed there or not. So now if I go to San Francisco and if I go to the tenant and application profile, even I can see the numbers here. So application EPG bridge domains VRFs has been increased. I have my web app. If I go click topology, now you can see here that yeah, it has been applied, and if we see the direction of the contract, so you will find that now we have two contracts. One contract here, DNS, he is the provider, so he is providing to whom? Web, that's correct. And the last contract that we have created, who was the provider? So app was the provider and the web was the consumer. So we can see the flow also, and it has been applied from the orchestrator or from the multi-site controller to the Epic controllers. Same thing I can go and verify to the other site also, that is the New York. So let me go and quickly verify that also. Let me log in here to this particular site as well, and then we will check that also. So I logged in inside the New York Epic controller. I can go inside the test tenant and inside the application profile, the web and app, and the topology. Once I am inside the topology, then I can check the topology. So let me scroll up so I can see this. All right. Let me fix the screen as well. So now here also I can see if I stretch it out, you can see the diagram. So from DNS to DNS is the provider going to the web, and again from the app is the provider going to the web. So we can see the flow. Alright, so we are very much done with this section. Let me stop here.
Now the last subsection we have here in section 3.0 is VXLAN EVPN. I have created the playlist for VXLAN EVPN as well. Here you can see that it will start with the basics of VXLAN. Then I have shown one lab inside the data center related to VXLAN EVPN. So this is the lab topology, and you will find this in that particular video. And then a step by step how we can go and do the BGP configuration and the VXLAN configuration. Everything is explained inside these playlists, inside these videos. So please go continue these 12 videos and you will complete this particular section. Now we are going to learn about VXLAN theory. So let's start with VXLAN overview. What is VXLAN first of all? At the moment we know that what is VLAN, virtual LAN, something that in a switch you can go and assign different multiple type of physical interfaces as a logical interface. So we know that what's the definition of VLAN, and VXLAN is nothing but the extension of VLAN plus so many other things. So we know that when we are creating the VLANs, VLAN 10 these two port, and then again VLAN 20 these two ports, etc. The limitation, although we know that VLAN is the numbering, and again we'll discuss about the limitation, but let's follow the slide. So he can see here that first of all, this VXLAN technology is a tunnel mechanism, and it is defined as a Ethernet in UDP tunnel. So what does it mean? Next recording, when we will go and discuss about VXLAN frame format, VXLAN structure, then we'll go and discuss more about what are the things we have inside VXLAN, what are the fields we have inside VXLAN, and then you will understand that it's a tunnel mechanism, and in every tunnel we have some inner fields, we have some outer fields. So inner and outer, those things we will discuss. But this is one of the technology using Ethernet in UDP tunnel encapsulation. And now here you can see in the diagram, this is purely IP network diagram. Means you have your infrastructure, and in this infrastructure we have underlay protocol, for example OSPF or ISIS or any other. Now these underlay protocols are working, and with these underlay protocols, all these devices they are using, in this case OSPF, so they are advertising the routes, they are getting the routes, etc. Correct? Now when we go and add the VXLAN here, so how things will get changed, that you will understand, and what are the features and capability that VXLAN will add into it. So already we have the underlay, and in that underlay what we are doing, that we are using overlay as a VXLAN. So now we'll see that at every point you have something called VXLAN tunnel endpoint tip. So now we have the tunnel endpoints, because we know this is the tunnel type of technology. And below you have OSPF or ISIS, that protocol which is supporting this VXLAN to form the tunnel. Because again, if you study tunnel, you know that you need some underlying protocol to form the tunnel. Because tunnel, what they're seeing what's the source and what's the destination tunnel. According to source and destination, they can go and they can work. So here the important point is this, that uh, while we are talking about the multiple tunnels, so suppose if this is a source, and suppose if you are talking about multi-destination communication, So maybe the source can send packet to D1, maybe the source can send packet to D2, and in between, if we have multiple routes to reach, so here you can see that you can go like this, you can go like this, means a source has multiple destinations. Now look this thing, and that's quite interesting inside VXLAN, and that's why it's very, very important. Now, you know what's the main capability of any routing protocol like OSPF, EIGRP, or ISIS? Now, these routing protocols, they are not forming any type of STP. That means they're not blocking any link. So suppose from one location to other location to reach other location, if we have three different path 1, 2, 3, and suppose all these path having equal distance, having same metric value, then you will find that you have three ECMP, three equal cost multipath. That means your source can reach to a fixed destination via three equal paths. Correct? And that's the same thing here we have. Now we have routed or routing type of overlay. So it is not depending upon something like switching type of overlay, because in switching type of overlay, again by default STP will come into the picture and will start blocking the link. So you have routed infrastructure, and all the destinations, they are only one hop away from the source, and that's why you are getting this enhancement. So now you can see that it has layer 2 multipathing. It is not supporting the STP, so there is no loop concept, although you may have layer 3 loop, but because everything is one hop away with help of clause fabric. Clause fabric is something which is dealing with leaf spine and leaf structure. That means that if you have two spine, you don't have leaf to leaf connectivity. Everything is collapsed or connected to the spine. And then if you have any entry, so from source to destination, if you don't know the destination, you are doing the proxy to the spine, and then the spine will tell you that this is the destination, how you can go it and how you can reach it. So similar logic to fabric path and include a scaling enhancement. And since this will support ECMP, since you are not building the list like in case of traditional MAC learning, you have to maintain the MAC database. Here you don't need to maintain each and every entry, because the spines can do for you. And again, this is the optimization method in terms of control plane. Now the MAC addresses this control plane can carry and import export. We'll check about this overlay technology later on in EVPN. But yeah, it has the scaling enhancement. It will scale the data center network, because inside data center you may have good amount of virtual MAC addresses as well. You may have tremendous amount of scaling that is going from east to west. Traffic means traffic from east to west may be big, maybe increasing drastically, etc. And one very important point here is that the number of MAC address support. So with the traditional VLAN, the number of MAC address support is only 2 to the power 24. Other very important fact, in traditional VLAN, we know that we have 2 to the power 12, that means approx 4K number of VLAN supported. And in VXLAN, you can see 2 to the power 24, it's a huge number. We can calculate it, but you can understand that how many VLAN segments we can create with this big number. Now let's understand that what are the terminologies used for VXLAN. Now before going there, there are some summary points that we have already discussed. That VXLAN is a nice way to maintain the control plane as well. So actually what it is doing, that inside the control plane you have L2 information. So you have the MAC learning, you have the ARP table, you have the BUM replication, broadcast, unicast, and multicast. That's the key here, that with help of control plane, so your control plane now able to understand the L2 related information, the layer 2 information, and that's why in upcoming session, you'll understand that how you can extend a network from one location to other location, and you can use same type of technology that VPLS is using. So you can do layer 2 extension. So from one data center to other data center, you can think as a DCI as well, data center to data center connectivity, and you can use MPBGP as a protocol. And since your control plane aware about L2 information, so you can extend or you can stretch the DC. Correct? Now the other thing that because it's using routed type of infrastructure, so either we can use OSPF or EIGRP, ISIs, etc. as an underlay, so that's why it is supporting ECMP, correct? And that's why it does not break layer 2 adjacency requirement. It will not break. It has a stateless vMotion, so you can take one of the VM from one DC and you can move it because you have pure solid underlay behind the scene, so the VM motion is seamless. It will work. It will allow multi-tenancy. Yes, you can create multiple tenants. You can create multiple logical network. Tenant means multiple logical network, and inside that you can go and assign the resources and it will work fine. In our lab also you'll find that we are creating tenant 1, and inside that we are going to assign all those VXLAN entries and the EVPN, etc. Then customer, you can see this separation of customers traffic over the overlay. Why? Because now you can create say tenant 1, tenant 2, so you have same hardware infrastructure, but on top of that you can create different type of tenants, and since you have different logical network, so you can segregate the customer network. Finally, allows for overlapping L2, L3 addresses like VLAN, IPs, etc. That's thing, because since we have multiple logical network, so and those are private to that particular tenant or the network, that means you can create multiple addresses, spaces, VLAN, etc. And you can reuse those things. Now let's understand the terminologies used, and to understand the terminology you can go and refer this diagram. So in this diagram you can see that what are the things you have. You have VTEP, you have tunnel endpoint, correct? These are your tunnel endpoint, these are your VTEPs. Then you can know that you have the overlay. So I have VXLAN overlay, but below this overlay you have underlay as well, and maybe you are running OSPF or ISIS. In our lab we are going to use OSPF. So you have underlay as well, and then you have the overlay, you have VTEP, then you learn your new term, and in the next session we are going to discuss more about VNID, VNet. So what's that? It's very much equivalent to what's VLAN number that we have discussed, but you have a good amount of number here. You can see that VNI, VXLAN network identifier, correct? So you will understand this is the identifier inside the VXLAN frame or inside the VXLAN packet, and with this identifier you will understand that where you are doing communication. So we need 100 to 100 or 100 200, etc. So now if you are doing the communication in same VNet, that means you are in the same segment. But suppose if you are doing the communication across multiple VNet, across multiple segment or logical segment, so at that time you need VXLAN gateways, correct? So what are the terms you have here? You have VTEP, you have VNet, you have VXLAN overlay, then you will find something called NVE. Now this NVE, network function virtualization encapsulation, etc. This NVE is nothing but your tunnel interface. And let me show you all these things. So overlay, we have discussed about that. VTEP endpoint, we know that your maybe Nexus 5K or maybe Nexus, maybe sometimes 7K as well, but Nexus 5K or any device where you have the VXLAN that you are configuring, this interface will be termed as a VTEP because this is your tunnel endpoint. So this may be source, and somewhere you may have the destination endpoint. So source and destination VTEPs, correct? But uh, how you are learning the endpoints, how you are learning the MAC addresses. So here you have, for example, servers. You may have switch and then you are learning the MAC addresses. But for example, I have one server, I'm learning the MAC address 1111, etc. So that's why you'll find that you have one switch port interface that is going towards the servers or local endpoint, and then you may have L3 interface, you may have SVI interface where you are forming the VTEPs. correct? If you have two different VXLAN segments, you want to do the communication, you need VXLAN gateway that we have already discussed. Then you have VNID. In the next section, we are going to learn more about this VNID and their usability and exactly where it is in the frame format. But this is the VLAN type of ID, and we know that ID can be up to 2 power 24, means it's a big number, and it will be sitting inside the frame, and you can go and manually define all the VTEPs participating in VXLAN. It's just the identifier. At this moment, we'll understand that this is the identifier, like you have the VLAN identifier. Then NV, network virtualization edge, or network virtualization edge, or encapsulation also we are telling that, but again it's a virtualization edge is a logical type of thing, means it's a tunnel interface. And whenever you have the VTEP, so one other usability of VTEP is that the decapsulation and encapsulation. So suppose you have your edge, you have your VTEP, and that's again your edge device. So when you are sending the packet in the overlay, obviously you will do encapsulation here. And when you are receiving the packet, obviously here you will do the decap, and then it will get to the receiving end. Correct? Then finally, you have the underlay network, and where you are running the OSPF, BGP, etc. Alright, so let's stop here, and next section we will learn the VXLAN data format in detail. Next important topic, we have a VXLAN encapsulation. Now let's understand that. VXLAN encapsulation means that you have your inner header, means obviously the payload and the inner header, where you have the actual source and destination. Then we have the VXLAN header, UDP header, and then the outer header. Now inside the VXLAN header, you have a VNID of 24 bits, and that's why we have possible 16 million segments. We have some reserve fields as well for future scope or purpose. Then you can see that we have the reserve, and one bit is on. That means that VXLAN is on, or VNID is on. So that's the VXLAN header. Then you have the UDP header, you have the UDP source and destination. I'll explain this in the upcoming slides. And then you have the outer header. So that means that whenever the packet will start, it will get attached with VXLAN header and the UDP header and the outer header, and then it will go to the next hop. Correct? So suppose if you go and do the packet capture, you can see the packet capture will look like this. You have the actual source, and then you have the actual destination. Then once you have the actual source and destination, you have the VXLAN header, and here you can see that you have the flag, and one of the bit is on. That means the VXLAN network is true, so condition is true. So you have the inner header, then you have the VXLAN, then you should have the UDP. Here you can see that you have the UDP source, that will be randomly generated number, and the destination is 4789 in case of VXLAN. In case of IVXLAN, that's used inside ACI, will be the different port, we'll see that. And then you have the outer header. Here you can see the outer header is nothing but the VTEP. So suppose if we have two leaf, these leaves are termed as a VTEP7 and VTEP2, and these VTEPs has IP 10.10.51 and 10.11.52. Correct? Then you should have some actual source and actual destination. Those actual source and destination having IP addresses like this. So once they will form the dynamic tunnel in between them. So I have two leaf, and then I am forming the dynamic tunnel in between them. So this is your VTEP, and this is your VTEP, where you are doing the encapsulation of VXLAN and UDP. And then from one location to other location, having available path, you are reaching out. Correct? Now, what are the interesting
fields or important fields we have inside this header format. Let me clean this. So here you can see that inside VXLAN header, we have these fields. Important one is the VNID ID, which is providing 16 million possible segments. Then about UDP header, you can see clearly that source will be the hash. So you can take any of the available path to reach to destination. But the destination UDP destination port will be fixed number UDP 4789, correct? So source may be something that it can take multiple paths. That's why we have the ECMP load balance with some fixed range of port number, and destination is one port fix 4789 to reach from one place to other place. Then you can go and check the outer header. Source and destination will be the VTEP addresses, and then you can check the outer MAC address as well. We have total 50 byte of overhead with the VXLAN header. Let me quickly go here, and you can see here some of the explanation about those fields. So we have 8 byte for VXLAN divided into these 4 parts. 3 bytes is used as a VNID to create the segments. Then we have the UDP header of 8 byte. The outer destination port is 4789, and inner source is the hash value in between. So here you can see the hash of L2, L3, L4 headers. So you can do the ECMP, correct? Then we have the outer IP header, and again the outer IP header will be nothing but the source and destination IP of the VTIPs. Apart from that, we have a checksum, UDP protocol, and the IP header miscellaneous data. Correct. So these information that whatever we have checked so far, these are belonging to the VXLAN encapsulation. Maybe in Nexus OS also you can go and enable the VXLAN, and then this will work like this. What about ACI VXLAN information? ACI VXLAN is termed as a IVXLAN because if you have two different EPGs, say EPG1 and EPG2, you need contract in between them, correct? So now if the VXLAN communication will happen, we have one extra field here for contract that will fall under flag. So we have SP and we have DP, and we have the PC tag as well that will tell you about the source EPG, and this flag means the contract is applied or not. So extra fields we have here which will tell that context is applied or not, the source EPG information is there or not, and then there is slight change in the UDP destination port. UDP destination port is 48879. Here you can see 48879. Okay, and this will be used inside the ACI. Although the entire IVXLAN configuration is optimized, we don't need to write single code for do this IVXLAN inside the ACI. What we need to do, simply bring up the fabric, connect the endpoints, create the rules policy, and then attach to the leaf switches what you want from source to destination, what policy, what VMM policy, what L4, L7 integration, etc., etc. And then the traffic will flow. We don't need to worry about the IVXLAN configuration because this is fully 100% optimized inside the ACI Fabric. Before starting the lab, let's understand a little bit more about VXLAN types. A VXLAN has three methodology for the communication. It can use flood and learn with respect to multicast, ingress replication if you don't want to use multicast, and then MPBGP based EPVPN. That in the lab we are going to discuss about that. And even in this course agenda, we have to understand, we have to actually perform the lab related to EVPN. So let's understand all three one by one, and then we'll go and perform the lab task. Now flood and learn, as the name suggests, that if you don't know the destination, you can flood the traffic across all the segments. But here where you are flooding the
traffic inside that multicast group that is attached with a VNID or VNet. So when doing the configuration for flood and learn, what we need to do is that multicast group knows the VNet. And when you don't know the BUM destinations, then for the BUM type of traffic, that's broadcast, unicast, unknown unicast, and the multicast traffic, you're flooding the traffic inside the same multicast group. Correct? So that's one thing, flood and learn. You do the flood and do the learning. Again, if you have large network and where you have good amount of end host machine, and in one VNet, if you have thousands of hosts attached, then it's not advisable that you use this method, but it's still mix and matches are possible. So in one switch, in one VNet, you are using one method, other VNet you can use other method as well. Correct? Now, what about the unicast packet? So you can see here clearly mentioned in the red that unicast packets to the host MAC are sent directly to the source VTIP as VXLAN encapsulation. So there is clear distinction in between the BUM traffic, how it is working. You are flooding that, but for unicast traffic, you are sending that traffic directly with the encapsulation. Next, ingress replication. In case that customer they don't want to use the multicast methodology to flood it, then other option we have that is to replicate uh, traffic. Correct. Now in the note section, you can see I have clearly mentioned that when we are using option 1, that's the ingress replication. So in that case, the leaf switch will be able to replicate a packet to every other leaf switch using a specific VNI. So here, who is doing the replication? The replication is performed with respect to leaf switch. But if you go and check the multicast method, so multicast method, in that method, we have the spine switch responsible to glue. So what is happening here is that inside the multicast group, we are sending that request to the spine switch, and then a spine switch, that's the core switch we have in this topology, he is performing the task on behalf of leaf. So you can see that it requires the spine switch to be able to replicate packet to all the leaf switches listening on multicast group. So clearly you can see that there is difference, and in ingress replication all the leaf switches they have the load, but in case of multicast methods that we are using, and again with respect to the third option we have, and that's the MPBGP L2 VPN, and we are going to use multicast here. Even here also we are using the multicast. So in those use cases, what is happening that your spine switch has to learn, and then they have to teach to the leaf. Correct. Let's discuss about the third option that we have, the MPBGP option. Now when we are using MPBGP, in that case, and again you can we'll see later on, we have one different slide in between the flood and learn and the multicast learning. You can see flood and learn and EVPN control, so we'll check that difference. But here you can see that in case of MPBGP based learning, so control plane learning for the host end, either it's L2 or L3, everything will be learn, understand with respect to MPBGP, multi-protocol BGP, because BGP has that capability to learn that. And then since now it is inside BGP control plane, then we can easily do the distribution as well. So either it's within the segment or it's going one place to other place, we can do the segmentation. But yeah, obviously when we are using BGP, so at that time we want to do the communication from one AS to other AS, or maybe from one data center where you have AS defined to other data center where you have other AS defined. Correct. And again, there may be different use cases. You just want to use these methodologies to do the communication in between the data center, or maybe if you have somewhere transit in between.
So maybe one data center is working at transit and two DCs, they are communicating over the transit side. So multiple use cases are there. L2, again, you can see that the EVP and VNI types, you may have L2, you may have L3. L2 means that within the same gateway, within the same VNet boundary, you are doing the communication. So A is doing inside A, B is doing inside B. But if we have L3, that means A and B, they want to do the crosstalk. So some host from A subnet belongs, he wants to communicate to subnet inside B, then he need the gateway, and the gateway learning obviously uh, can be happen with the EVPN. We'll check this later on. And not this is a specific to one data center. So maybe your VLAN A is in DC1 and VLAN B is inside DC2, and then you have some gateway, some bridge with respect to MP, BGP, EVPN, and you want to do the communication. Again, here you can see that the VTIPs, so these edge switches, they are learning the MAC addresses, and you have L2 and L3 VNI defined. Again, L3 is there, that the bridge between L2s. So if two L2s want to do the communication, your bridge will come into the picture. Configuration we will see in the upcoming section in the lab. Great. So what advantage we have with MP-BGP based methodology? So in that case, you can see that minimize the network flooding through protocol driven host / MAC route distribution and ARP separation on the local VTIP, because clearly you are giving that task to the spine. And again, we have the communication method with respect to multicast. Even we can use anycast, and in our lab you will see that we are using anycast, multicast, and with anycast methodology. That means that one to nearest. So we have three methods: unicast, one to one, multicast, one to group, and then anycast, one to nearest. We'll see that how we'll go and enable the PIM, and then we'll go and configure the anycast, because if we have multiple spines we can use that methodology. So that's one thing, that the flooding will get reduced. Second, that provide optimal forwarding from east to west and north to south. So that's true, because now you have one central control plane, and that control plane is aware, that is running BGP. And now we know that BGP, how robust is this, that they can easily understand north to south traffic, and for east to west obviously we have the VXLAN overlay defined. And then finally, that provide VTIP peer discovery and authentication, which mitigates the attack and provides security inside the network, inside the overlay. So these are the important points we have here related to the VXLAN and their types. Now in the final slide, you can see this is the summary slide. You can see the difference between the flood and learn and EVPN that we are going to use in the next section. So the overlay services L2 plus L3, they are providing both. Underlay, you can use any protocol like IS, OSPF. We are going to use OSPF in our lab. Then this both the technologies, they are MAC and UDP that we have already discussed. The peer discovery they are doing with MPBGP in EVPN. The peer authentication is possible in EVPN methodology. The host route learning, here you can see the route learning. Local host is data driven. Obviously, the switches where you are connecting the service, they are learning that locally. And the remote host, we are using some L2 VPN learning method to learn the remote host. Host route redistribution, distribution we can do with MPBGP. L2, L3 unicast forwarding, we have unicast encapsulation, both the places. This we have discussed earlier, that for unicast traffic you can do the encapsulation and send it. Bump traffic, here you can see that multicast replication, unicast ingress replication, both. So you can see that there are less differences here, and that's why this flood and learn is also useful. It is used at several places, but mostly you'll find that EVPN control plane methodology is most popular, highly popular. So if you have small data center and if you want to do the extension of L2 or you want to work with your overlays, it's very easy. You can go and do the flood and learn configuration. But if you want some more features, benefits, like authentication and the extension, and that your control plane will learn the MAC host, ARP entities, etc. So you can use MPBGP. And now Cisco is using MPBGP type of methodology inside the ACI, correct? So if you go and learn the ACI Fabric, you'll find that Cisco in the data plane we have something called IVX LAN, but in the control plane learning and extension of control plane, MPBGP is working there. And it's very easy to use MPBGP inside the ACI Fabric, although it's very easy to use VXLAN as well because we don't need to do anything. VXLAN is 100% optimized, means there by default there in ACI. Alright, so let's stop here and next section we'll start our lab.
Let us quickly discuss about our lab topology and the underlay configuration. Here you can see in our topology we have two spine, spine 1, spine 2, and these are the respective loopback addresses to them. Now these spine and these leaves, so these leaves they have actually dual homed, means I have back-to-back connection with the spine, and the interfaces we can see, say from spine 1 I have ETH 1/1, 1, 2, 1, 3, 1, 4. From leaf I have E11, E12, and then one is going towards the server. So likewise we have same sort of interfaces that is going towards spine and that is going towards the server, that is used here in this topology. This topology you can see that it's fairly easy topology, and I'll show you what is the IP address configured here in this. But we are running OSPF as an underlay protocol in this particular infrastructure, and in the next section we'll learn we will going to configure iBGP. So here with all these leaf and spine structure we have iBGP relationship where my spines are acting as the route reflectors. Okay, and then finally I have one WAN router, and then again it is connected with one of the server. So let us go to the next slide and check that what IP address schema is configured here. Here you can see that say from one leaf, that is the dual home, one interface is going towards spine 1, one is going towards spine 2, and these are something like P2P configuration where I have enabled OSPF. Okay, so let me quickly go to the CLI, and from there I'll show you the IP addresses and the OSPF configuration. Here you can see the configuration and what is the IP address configured over the loopback and the physical interfaces. These physical interfaces are the point-to-point interfaces obviously. And let me go to the spine 2. You can take a notes like this, then leaf 1, leaf 2, leaf 3, and then the final leaf 4. Okay, so whatever there was there in the slide, the same type of IP address schema we have. So let me show you one of the interface, at least one or two interfaces. So let me show you say loopback 00 and E1/1. So I can go here, I can check loopback 0, and then I can check say E1/1. So suppose if you want to check 1/1 up to 4, you can use this command. Here you can see that description as going towards leaf 1, leaf 2, leaf 3, leaf 4. They have /30 as a IP address because this is the point-to-point type of configuration, and in the OSPF as well we have IP OSPF network point-to-point configured. Let me quickly show you the OSPF configuration as well. So what I can do, I can go and check OSPF, and I will send this script to all. Here you can see
OSPF, then the router ID as a loopback. Then over all the interfaces we have this OSPF running like this. And then finally what I can do here, I can go and run this script that we can check the underlay routing information that these devices are learning. So I can do show IP route with respect to OSPF, and let me send this script to all. Let me execute this command one more time. So here you can see that this command, no problem, it is up and running, and here we have the OSPF routing information. Let me type show IP OSPF not never but show IP route OSPF. Obviously because these are the point-to-point network, so you will get all these neighbor relationship. They are in the full state. That's okay, no problem on that. But here in the route as well you can see all the routing update or information inside this leaf and spine structure. So likewise we can check the OSPF or our underlay route as well. Okay, so these are the information related to our the IP address schemes that we have, and then what type of OSPF configuration that I am running in this particular infrastructure, and then finally you can check the show OSPF routes and the neighbors as well. In this section we'll learn that how we can create the IBGP relationship between the leaf and the spine. So we have 4 leaf and 2 spine, and those leaf and spine relationship are multi-homing. That means from all the leaves we have 2 IBGP peer connection or relationship. Let me draw little quick that what is our leaf and spine structure here. Let me go back. So what I'm telling, let's say I have a spine 1 and 2, and then I have 4 leaves. Here I have pure IBGP relationship, and these leaf to a spine. So this is my leaf and this is my spine and this is my leaf. From leaf to a spine I have IBGP dual home connection. And how I am going to achieve that, here you can see in the PPT that from spine the configuration is, first of all, enable router BGP. Obviously first of all we need to enable the feature BGP. Then we will start the BGP process, assign the router ID, IPv4 unicast status, and there you can see that I am creating template for all the IBGP neighbors. This template I will attach, say, for .8, 9, 10 and 11. These are the respective loopbacks for the leaf that we have. Okay, so once I do this configuration on a spine 1, then the same type of configuration I'll do with a spine 2, and I'll change the loopback address from .6 to .7. That's it. Rest of the configuration will be the same. Then I will go to the leaves, and from leaf we need to create again IBGP relationship for .6 and .7. Those are the spine 1 and 2. Okay, so only thing or only command that will change, that is the router ID inside the leaf, and then instead of .8 I have to put 9, 10, 11 like that. So that will complete all the leaf and the spine configuration. Once I've done that leaf and spine configuration, then we'll do the verification. I'll go to the spine 1 and we'll check show IP BGP summary, and then we'll see here in the output that do we have 4 IBGP relationship, say with respect to leaf 1, 2, 3, 4 or not. Okay, so let me log to my devices, and then I'll show you all the configuration step by step. So first of all, we are going to configure spine 1. So let me log to spine 1. In spine 1, first of all, I need to go to global configuration mode, and then I need to enable the feature, say BGP. Once my feature BGP got enabled, then I will configure rest of the BGP stuffs. So let me do the configuration for the entire BGP rest of the things. Okay, so first of all, I will enable router BGP 65000. That will start the BGP process. Then we'll wait for few seconds. Then router ID, say 192.168.0.2. Then address family IPv4 unicast. Now from here I want to create template, and the name of template, so template peer, the name I can give say leaf and then peer, like that. Now from here I need to give all the commands, so my remote AS, so let me give the remote AS first, 65000, update source as loopback 0, address family IPv4 unicast, then send community, and I can use as extended. Even we can use both as well as a common, both will send the standard and the extended community attributes. And then finally I can do the route reflecting client. So once I do this configuration, then what I can do, one by one I will attach this with all my leaf, all my neighbors. So now I can do one thing. Now I can type say neighbor is 198, say 192.168.0.8, and then inherit peer, and then the name of this, say leaf, and then the hyphen peer. Okay, so once I do this configuration, after that simply I need to change the neighbor IP, and then I have to attach this to all the leaves or all the neighbors. So let me do it quickly. Next time what I'll do, I will give 9, and then this, then we have 10 peer, and then finally I have 11 and the peer. Now I can go to BGP. So if I check show run BGP, here you can see this is my configuration, and this configuration actually I can copy and then I can paste. But here you can see this is not the router ID. My router ID is 0.6, not 2. So let me quickly change that. 65000, and then router ID 192.168.0.6. We'll see that this router ID will change or not. And again I'll check show run BGP. So here it is showing that the router ID is changed. Now I'll copy and paste this configuration to the spine number 2 as well. So what I will do, that I'll copy from here. Okay, so let me go and open my spine number 2. Inside spine number 2, first of all let me enable the feature
BGP. Then let me start the router BGP process. We'll wait for 3 to 4 seconds. Then I need to assign the router ID, this time the correct one, 192.168.0.7, and then the entire configuration that I have in spine number 1 I have assigned to a spine number 2 as well. Then from here I can check BGP configuration, 7 peers, so everything seems good. Now let's quickly move to leaf number 1, and in the leaf number 1 also I need to first of all enable the feature BGP. Once I enable that, then I have to do the rest of the configuration. So let's quickly do the rest of the configuration. And the rest of the configuration, this time I need to first of all enable the BGP. So router BGP 65000 will wait. Let me assign the router ID first, 192.168.0.8. Then address family IPv4 unicast. Now for neighbor, that is 192.168.0.6, that is one of my spine which has the remote AS of the same 65000. Okay, so let's quickly verify this configuration first before moving further. I am enabling the router BGP, then the router ID, then address family IPv4 unicast, correct. Then my neighbor, this, and the remote AS is this. So what I can add here, I can add update source loopback as a 0 here as well. Okay, so let me add that, say update source loopback 0, and the same configuration I have to do with 7 as well. So what I can do, show run BGP. Okay, so for the neighbor, that will be 7. I need to do the same. And address family will be IPv4 unicast, and send community both. Okay, so I have done a little change of configuration here just to verify this. So what I have done here, that for .6 I have used this much only command, but here I have added send community, say both. That was my command. Okay, and then I have added address family IPv4 unicast. Now what I want to do, I just want to quickly verify, show IP BGP summary. That my neighbor is up or not. So here what I am seeing, that with respect to 7, that is the spine number 2, it is up, correct, but it is not up with respect to 6. So that means again I will go inside router BGP 65000, and then I can mention my neighbor. So let me mention the neighbor, that will be 6, this one, and then address family IPv4 unicast, send community both. Now if I check show IP BGP summary, just to check my BGP neighbor relationship,
both are up. Okay, so finally this configuration I need to add to all the devices, correct? Only thing is there that the router ID will change. So what I will do, I will copy and paste up from here to all the leaf switches. So let me quickly go to leaf number 1, enable the feature called BGP, router BGP 65000, then the router ID 192.168.0.9, paste it. Parallelly, leaf 3, conf t say feature BGP, and then router BGP 65000, router ID 192.168.0.10 this time, the same thing. Okay, so let me go and paste these things to leaf number 4. Finally the router ID 192.168.0.11, and then finally the configuration. So from here, once we've done all this configuration, then what we want, we'll go to the spine number 1, and from spine number 1 we'll verify the BGP neighbor relationship, and here you can see, even you can see the order as well. In this section we are going to configure multicast to support BUM, that is the broadcast, unicast and multicast in the VXLAN fabric. Now it's very important here to understand that while we are doing the configuration, at that time we need to consider a few points. What are those points? Those points are the underlying multicast infrastructure will be used for BUM traffic, that is the broadcast, unknown, unicast and multicast traffic. That is one point. The other point, the RP configuration is not supported on leaf switches. So these RP configurations will do over a spine. Okay. And the other important point here to understand that it is recommended to configure RP only on the spine node and use the Anycast RP, that is the rendezvous point model, for the load balancing and the redundancy. So these are very important points that we need to consider, and while I'll do the configuration, I'll show you the entire configuration step by step. Now if you see the configuration or whatever things we need to consider here. So first of all, we need to enable the feature, enable the PIM. Okay, so first of all I have to go on the Nexus switches and type say feature PIM. So that will enable that feature PIM. Then configure spine and leaf interfaces for PIM. So these are actually very important points. The point number 1 is to enable the feature. Point number 2 is to configure the spine and leaf interface for PIM. You'll see that. And here I'm going to use the IP PIM in the sparse mode. Okay. Enable router OSPF on loopback interface. That also I will show you while I'll do the configuration. Then enable Anycast RP between the spine switches. So these are the consideration, or these are the configurational points that I have to do here on the spine and leaf. Here inside say spine number 1, what I am doing, so we'll do that step by step. And here you can see in the notes that enter the following commands on spine 1 and 2 to configure the PIM and the OSPF on a new loopback interface. Since this is Anycast, the configuration commands are same on both the servers because they are RP rendezvous points. So these are the configuration that the same type of configuration I'm going to enter on a spine 1 and 2, and these are my Anycast configuration. This configuration are same, and we'll see that how they are used by the Anycast configurations. So I'll create one new loopback, say loopback 1 with this IP inside IPPM in a sparse mode, and then I'll enable the IP router OSPF on that, and then I'll go to spine 1 and I'll do this configuration. Here in this configuration you can see that my rendezvous point is mapped say with spine 1, then it is mapped with spine 2 like that, and then rest of the interfaces I am enabling PIM. That's it. Likewise the same configuration I'll do to a spine 2 as well. So same configuration I have here as well. Then I will go and configure leaf 1 to 4. So leaf 1 to 4, these leaves they only know, okay, this is the way I can reach to the RP. What is the RP address? So I'll go and configure the RP address to all the leaves, leaf 1 to 4, and then I need to enable the IP PIM in a sparse mode to all the interfaces participating in this VXLAN. Okay. Once we'll do that, then we'll check IP PIM neighbor. So these are the steps that I'm going to cover in this particular section. Let me log to my devices and I'll show you all these steps one by one, all this configuration one by one. Here I am inside my spine 1 and let us do the configuration. So first of all, what we need to do here, and let me take it here so you can see the configuration. I need to enable the feature PIM. Then I'll go and I'll create a loopback 1 with the IP address a 192.168.0.100. This is IP PIM in sparse mode, and then IP router OSPF area is say 0. Same configuration that I have shown you over the slides we are doing here. So once we'll do this much of configuration, then I have to do configuration related to multicast. This is also related to multicast, but the configuration that is used for a rendezvous point and Anycast, we need to do that. So let me do that configuration. Say IP PIM and the RP address will be, because this is the RP address and this particular spine is the RP as well. Then IP PIM, say Anycast RP 0.100, and then I will map it with 192.168 say 0.6, that is its loopback 0 address, and then I'll map with 7 as well. Then I have interfaces, say interfaces E1/124, where I want to enable IP PIM in a sparse mode, and then finally I have interface loopback 0. There also I want to enable IP PIM in a sparse mode. Okay, so these configuration, the same configuration I have to put inside the other spine as well. So let me quickly check the PIM configuration. Here it is. So first of all I need to enable the feature called PIM, and then the RP address. These things you can see that we have already there, but let me go and do the same things inside the spine 2 as well. Let me open that. First of all, feature called PIM. Let me fix my screen so you can see it. Okay. Then the same steps I'm going to do here. Then I'll go to loopback, say 1, and IP address, say 0.100/32. IP PIM in sparse mode. Then IP router OSPF, say 1. Area is 0000. Okay. Then I will exit from here. The RP address, I need to assign that. This is my RP address. Then IP PIM anycast RP. So this should map with 6 and 7. Then I'll go to interface E1/124, and there I need to enable IP PIM in sparse mode. Finally, I have interface loopback, say 0, because 1 we have already enabled that. We can check show run PIM. Okay, so now we have the configuration related to PIM. Parallelly, I'll go to the leaves. So let me go to the leaves, and first of all I need to enable the feature called PIM. Suppose if you want to save your time, you can go here, you can enable that feature, and you can send that to all the leaves. Okay, so here I need to go inside the global config, and then I have to send that. No problem. I'll go to conft and then feature PIM. Now we'll send that. Okay, so here on all the on all the leaves we have same type of configuration. Let me fix this screen first. We'll do the configurations once it will come up. So what configuration I have, I need to give IP PIM. The RP address is say 192.168.0.100. Then the interfaces. So interfaces E1/1 up to 4, and these are IP PIM in sparse mode. And then I have one interface loopback 0. Okay, that's it. So this configuration I need to put on all the devices. Let us go to the tools. I can paste that configuration. This is the first. Then say interface E1/1 up to 4, IP PIM sparse mode. Then interface loopback say 0, IP PIM in a sparse mode. That's it. Let me send this to all the devices. Let us quickly verify. Let's quickly verify to E13 is not in. Okay, so in these devices I have only E11 and 12 because we have only two uplink that is going towards the spine. So from here I have E11 and E12, and then I have E13 that is connected with server. So that's why we have this error, but anyways it's okay. Now if I check this inside any of the show run interface E1/ or show run PIM, so we are checking in any of the leaf, and here our configuration is very small, simply IP/RP address, that's it. And then I can go inside the spine for the verification. For verification we can check say show IP PIM and then the neighbor. So if everything is okay, you can see here that we have 4 neighbor, and that's the configuration that we have done. So from our leaves, because I have 2 spine, 1, 2, 3, 4, we have 4 PIM enable interfaces. So that's why we have 4 neighbors here. The same thing I will go and check to the spine number 2 as well, and here also I can check show IP PIM neighbors. Here it is. Okay, so we are very much done with this particular section. This is very important segment where I have to map my L2 VLAN with the VNI. So here you can see that VLAN to VNI mappings, and in this table you can see that I have say VLAN ID 140, I am mapping with the VNI ID 50140, 141 mapping with VNI this, and mapping with this multicast group as well. Then finally I have L3 VNI where I am mapping with this VNI. Okay, so this portion of configuration is actually very important to do this VXLAN overlay, and for that obviously we need some sort of features to be enabled. These are the features that will be enabled say for NV overlay. Then we have this VLAN to VNI mapping, so feature VN segment VLAN based. Then we have NV overlay EVPN to enable the EVPN feature inside the switches. Finally I'll go to all my leaf switches, say leaf 1 to 4, and then the VLAN to VNI mapping, VLAN to VNI mapping. That's okay, that's the one portion, one part. Finally I have to create the VRF as well. Once I create the VRF, then I will go inside the say interface VLAN, and there I will map this with a certain VRF. The forwarding fabric is Anycast gateway because yeah, we have the Anycast configuration over the spines. So this configuration say for interface VLAN 140, then the configuration for 141, then the configuration for VLAN 999, and finally I have to create the NVE interface, that is our say network virtualize interface. This is actually the glue between my underlay and the overlay fabric here. So this portion I think that come twice, so we need to configure once. Here in this configuration you can see that inside the NVE interface I am mapping my loopback, I am mapping my VNI with the multicast group, VNI with the multicast group, and then finally I have two very important commands. One is host reachability protocol BGP, because for our EVPN we are going to use BGP, and inside that BGP I need to enable the address family called EVPN. And then finally I need to associate the VRF, and this is my L3 VNI that I am using here. So these are the commands. Once I'll do complete all these commands, then I can go and check the NVE, where I'll find that yeah, these are my L2 NVE, or these are my L2 VLAN to VNI mapping, and this is my L3 mapping, and everything is up and running. Okay, so let's just go back and do the configuration to all these leaf and the spine switch step by step. So let me log to my device first, and first of all I will enable the feature. So what I can do here, I can simply run a script to enable the feature. So let me go inside the tools and let me send the scripts for the feature. So feature is a NV overlay, then I have say feature, so I can like type like this, feature VN segment VLAN based, and then finally I can give NV overlay EVPN. Okay, so let us send this script and we can quickly verify. Seems that a script has run to all the devices. So once we'll do that, then what is the next thing that I have to do? The next thing that I have to do is to create VLAN and map to the VNIs. So rest of the configurations are related to leaf 1 to 4. What I will do again here, I can go to the script and then here let me select none. Let me quickly check with leaf 1 and then the same configuration I'll send to all the other devices. So my spanning tree, say VLAN 1 140.141.999, that is the last one. Priority is say 4096. Let me send this script. Yeah, that's correct. Then finally I have to do the configuration. Okay, so what I can do here, even I can type all these things in a notepad and paste here just to save our time, but from a script also you can learn this. So now I will do and execute the commands over all the leaf switches, say from leaf 1 to 4. Okay, so let's open the script. Now next what I want to do, I want to create VLAN 140. I want to name it. Say this is L2 VNI 1404 tenant 1, and the VN segment is 50140. Correct. Likewise I have say VLAN 141 and the name is say L2 VNI 141 tenant 1, and the VN segment is 50141,
Finally, we have VLAN, say 999, and it is mapped with the VN segment 50999. That's it. Let's send this script. So while creating this VLAN 141, so we'll get such type of errors. We'll ignore these errors. And now if I do show VLAN, so I have VLAN 140, 141 and 999. They are active. Let me quickly verify on the other leaves as well. Great. So now one part of configuration we have done. The second portion, what I want to do, so let me go to the tools and the script one more time, and from here let me exit. We want to do the configuration for the VRF. Okay, so let me create the VRF. I want to create the VRF called tenant 1 and the VNI 50999. RD is auto. Then the say address family, correct. IPv4 unicast. Then the route target both auto. So I'll do a small scripts configuration, because if we have some problem in even in the spelling, then we need to do it everything again. Okay, so I'm doing small chunks of configuration one by one. Here I can give auto but with EVPN. Let us send this configuration first. Okay, so this way we can create the VRF, and inside that VRF we have some other commands as well. So let's complete that. We have some small commands like fabric, say fabric forwarding anycast gateway MAC 000 say 222. Okay, this command is actually a big one that you can refer from the slide. Now once we'll do this configuration related to my VRF, what is the next task? Next task is to go inside the interface VLANs and then map this VRF inside that. Okay, so for that I need to go to the interface VLAN, but because this is a specific configuration related to a leaf, so that's why I have to go one by one to the interfaces. Even most of the commands will be same, that I can create a template in the notepad and I can use it, but anyways I'll copy paste from the putty itself. Okay, so let me go inside interface VLAN say 140. First of all I will do the no shut, then VRF member say tenant 1, no IP redirects, IP address is say 172.1.1/24, and then the fabric forwarding mode is anycast gateway.
Okay, so likewise I can go to the other SVIs or the VLAN as well, say 141, no shut, and the member will be the same, no IP redirect will be the same. The IP address I need to change, and here I can give say 141, and then the fabric forwarding mode anycast gateway. Finally I have interface say VLAN 999. The VRF is say tenant 1, and then the IP forward. Okay, so this configuration I need to do on all the leaves, and here you can see the configuration is same. Even I can write a script and I can do it. Okay, so VLAN 140 141 and then 999. Let me go and copy paste in the notepad, and let me do that configuration. Notepad, correct. Then here as well we'll do the configuration, and then finally this section. So this is my final configuration on all the leaf switches. Okay, let me quickly paste this. Even you don't want to go hop by hop, you can go and paste this to the script, and from the script it will automatically take this configuration. Okay, so let's just stop here. We'll continue from here in the next section. Let us complete the configuration. So now I need to create the NVE interface. So for that I can go to global configuration mode, interface NVE, say 1, and then I can do the rest of the configuration. My source interface is say loopback 1. Host reachability protocol, I am using BGP. The multicast, so let me quickly check that what options I have here. Here you can see that options, advertise, config source, mcast routing, the source interface, suppress, all these options I have. So let me do the member first, and the member is a VNI. I know what is my VNI ID, that is 50140, and then the mcast group is a 239.0.0.140. Likewise, the other member I have, that VNI is 50141, and then the mcast group is a 239.0.0.141. Okay. Finally, the other important command, that is the VNI 50999 and associate with the VRF. Let me show you the configuration for this NVE1. So we'll do like this: show run interface NVE1, and this is the configuration. Okay, so my NVE interface, protocol reachability BGP, and these are the VNI I'm mapping inside this NVE interface. This configuration I will paste to the rest of the leaves. So let me do that. I'm pasting the configuration. So once I paste all these configuration, then what I will do that I'll go and quickly verify the configurations and the options related to that. So let's do the verification. What I can do here, I can check show NVE VNI, and this is actually very important output. Here in this particular output you can see that I have say L2 VNI here, and then I have L3 VNI. These L2 VNI are mapped with the multicast group, you can see here, and then finally I have L3 VNI. Everything is up and running. So the same thing I will check with all of the leaves. So let me go to my other leaves, say leaf 2, 3 and 4, and we'll check show NVE VNI. This is also good. Let us go and check to leaf 3 and leaf 4 as well. This is also good and up. This is also good. So inside leaf 1, if you see what other options you have with NV, you can see here that you have options related to BFD, that is bidirectional forwarding, VNI, peers, internal interfaces. Some other options also we have. If I quickly check VRF, so here you can see the gateway MAC address and the VNI ID. So let me quickly show you the configuration that we have done so far in this particular leaf switch. So we have done the configuration, say with respect to NVE. That was our last configuration. Apart from that, we have configured the VLAN interfaces, say 140, 141, 999. If I check my VRF, say tenant 1, this was the tenant 1 configuration, and then we have enabled some of the features. So if I simply check the features and exclude or include enable, we can see that what types of features are enabled here. So we have NVE, that is enabled, VN segment. Okay, so this way we can verify our configuration, and finally we have done some configuration related to PIM as well. So you can check your PIM configurations as well. In this section, the agenda is to configure the BGP EVPN control plane, and for that what I have to do, I will go to spine 1 and 2. I will enable the address family called L2 VPN EVPN, and then I have the template called peer leaf. So whatever peers we have, there again I will initiate this address family, that is L2 VPN EVPN. I'll send the community both, and this will be used as a route reflector client. So this is the configuration over spine 1 and 2. Over the leaves as well, we need to enable this address family. So in the leaves also I'll go and then I will enable the address family called L2 VPN EVPN. Then obviously I'll retain the route target all. Then for neighbor 0.6, that is a spine 1, I will go and configure these things. Means here also I need to create BGP relationship, but in terms of L2 VPN EVPN, and with
1.7 as well, I have to create the same address family like this. So once I do that, then I need to create the EVPN as well. Here you can see the EVPN related configuration to configure RD and RT for the VXLAN bridging. So here my VNI say 50140 with respect to L2 VPN EVPN. What I am doing, RD is auto and the route target import and export auto. Likewise for other VNI 50141, the RD and route target I have to configure. Okay, so once I do the configuration up to this point, we are very much done with our control plane configuration with respect to BGP EVPN. So let me log to the devices and then we'll do the configuration for the spine and the leaves. First of all, let us configure the spine. Let me open the CLI for the spine 1. Here inside the spine, I'll go and enable the L2 VPN EVPN address family. Okay, so let me just fit the screen here. Yeah, I'll go inside our router, say BGP 65000, and then the address family is say L2 VPN EVPN. I want to retain my route target all, and then we have the template say for the peer leaf. So whatever leaves I have, I can use that template, and then I can give say address family L2 VPN EVPN. Finally I can send community both, and then the route reflector is client. Okay, so this configuration I need to do for my other spine as well. So let me copy and paste in the notepad. Okay, so same type of configuration I'll do. Let me filter it. Okay, so here you can see the piece of configuration that we are enabling the address family, and then inside that address family you can see here is the address family. We are sending the community and we are making this particular address family, or we are enabling the route reflector inside this particular address family. Okay, so let us go and paste this configuration to spine number 2. Once we are done with this configuration, then we'll go and configure the leaves as well. Inside leaves we have to do several configurations. We'll do that. I just wanted to make sure that I configure all the required steps. Retain template address family both. So retain address families and community both. Yeah, otherwise we need to do some troubleshooting if we miss any portion of the configuration. Let us go to leaf number 1, and inside leaf number 1 we'll do the configuration related to control plane. So let me fit this screen. Yeah. So conft router BGP 65000, say the address family is L2 VPN EVPN. Here also I want to retain route target all, and then the configuration related to neighbor. So my neighbor is 192.168.0.6, that is the first spine. The remote is of 65000. Address family is obviously this time is L2 VPN, EVPN, and finally send community both. Okay, so this configuration is related to 6. Now I want configuration related to 7 as well. So what I will do, I'll create one template for 7 as well, and I can paste to all the leaves, or we can create a script and we can paste everywhere. So let me do it a little quick. Then address family is L2 VPN, EVPN, then the send community both. Okay, so I want to copy paste this to all the leaves. Let me check show run BGP. This time this configuration retain, so you can match the configuration here. The router BGP address family retain, and then 6, then address family, then send community. So till here. Okay, up to this point I want to copy paste to all my leaves, so let me go and do it little quick. And then finally leaf number 4. Okay, so once we are done, now we have to do the configuration. That will be the final piece here with respect to our VNI or EVPN. So what I can do here, I can go inside EVPN, and inside EVPN I need to map the VNI. So VNI is 50740, and then if I type question mark here, you can see L2. Here I can give the RD and route target. So let's check. Yeah, RD. Then the route target. Import and export I can use both. Auto. Okay. And I will check show run EVPN. Show run say grep EVPN. Here you can see that inside EVPN we have some configuration that is not coming here. So what I'll do, even I can check show run. I just want to check the EVPN configuration. And this is the EVPN configuration. This configuration, now I have only 50140. I need to add say EVPN VNI 50141 as well, correct? RD auto, and then the route target will be both auto. So EVPN is coming, but it's not coming in the desired format. But anyways, let's check this first. We'll copy and paste this configuration to all the leaves, and then we are very much done for this particular section. Okay, I'll go and paste. So we are very much done with this section. Let's just stop here. Now we are done with the configuration. Let us verify. So for the verification, if you refer the topology diagram, you'll find that our leaf 1 is connected with one of the server. So we need to do the configuration for that as well. And the leaf 3 is also connected with one of the server. So for that also I am going to do the configuration. And then we'll send traffic over VXLAN fabric. Okay. So here you can see in this slide that okay, these are the interfaces connected, and I'm going to do the configuration with respect to leaf 1 for VLAN 140 and VLAN 141 for my leaf number 3, and server 1 and 3 are connected. So once we'll assign the IP address and added the route to the leaf, you can say the server 1 and server 3, then we'll do the ping test between server 1 and server 3. Okay, and the IP address I'm going to assign is 172.21.140.10 and 141.10 respective to server 1 and server 3. So let me open my servers. So here I have server number 1, and I need to add first of all the IP address and then the route. So let me do that. So what I can do here, I can use the Linux command because these are the Linux based servers. So over eth1 21.140.10 and then the net mask 255.255.255.0 status is up. Then the next I want to add a route. So route add to the network 172 say 21.00/16, and the gateway is 172 say 21.140.1 eth1, and then let me do the ping. So ping to 172.21.140.1, that is its gateway, and we'll wait. So it should ping to its gateway first, and then only we can do end-to-end ping. So what I am doing here, let me stop this ping first. Simply I am trying to ping over this particular SVI interface, and I have done the configuration for my say server 1, that is .10, and I am pinging over this leaf 1, that is .1. So let's go and do the configuration for leaf number 1 inside the SVI, that is 141. So we'll check the SVI VLAN 141 first. One 172.21.141.1 and 0, because this is inside the VLAN 140, so we need to reach here first. So for that I'll go inside E1/3, that is my switch port. So switch port access VLAN 10. So I'm doing simply the VLAN specific configuration here. Obviously this should be no shut. Let me go to server number 1. So still it is showing that
this is unreachable, it should ping first. Let's see the configuration. 1/3. So switch port access VLAN 10. That's correct. State is up. 1/3 is down. It's inactive. Let me quickly check this, why this is showing down or inactive. I have simply done no shut to the interface and it is coming up now. We have, let me show you the configuration. This is the configuration. Okay, let me check to my server number 1. Now you can see we are able to reach. Now parallelly what I'll do, I'll go to this particular leaf switch E1/3, make it switch port, no shutdown, say switch port mode is access and switch port access VLAN is 141. If I want I can give description. This is server number 2. I'll check show run interface E1/3. Okay, and then show interface E1/3. Now this is up. So let me quickly go to server number 2 and here I need to add the IP and the route. So what I can do here now, sudo if config eth1 172.21.141.10 this time, because this is 141. Net mask is the same 255.255.255.0 up. Then we can add a route, sudo route add net 172.21.0.0/16 gateway 172.21.140.141.1 device is eth1 and that's it. Now if I ping to the gateway, so let me check that. It should ping. Now you can see. So here from my server side I am able to ping to its gateway. There is no problem on that. So from server number 1, server number 3, I am able to ping to leaf 3 and say leaf 1. Now I want to do this end-to-end pinging. So from server 1 I will ping server 3 and then we'll check the VTEP tunnels. Okay, so let me go and ping from server 1 to server number 3. So here I am. Let me ping this IP address, that is .10. Okay, so it is tried to pinging and still I don't have any response at the moment. We'll wait, and parallelly I can go to leaf number 1. I can check show NVE peers. Moment is showing no NVE peers are there. I can check show IP route VRF for say tenant 1. Here also we are not able to see the routes specific from one tunneling point to other. Still we don't have any responses. What I have done, I have added back all the BGP configuration. Here you can see on your screen, and after that everything is working. Let me show you the BGP configuration here in the Notepad++. So here you can see the BGP configuration for spine 2, 1, then the leaf 1, 2, 3, 4. What I will do that with this particular PPT, I will share all the configuration files, all the configuration. I will embed inside that PPT so you can refer these configurations. Okay, so once I added back all the BGP configuration, now you can see that my neighbors are up, and in the leaf as well. So here you can see I have added back the configurations. So in all the leaves, leaf 1, 2, 3, and then if I go here to leaf number 1, if I check show NVE peer, you can see that I have my NVE peer, and if I go to server number 2 and if I ping say to server number 1, that is 140.10, I am getting the end-to-end ping response. I can go to my leaf number 1, I can check the NVE peer, my NVE means my VTAP tunnel is up. If I go to say NVE, say leaf number 4, here if I check NVE peer, that is up. You can see the uptime, you can see the router MAC. There are some other verification also that we can do. So I can check now show IP route VRF tenant 1, and here you can see this VXLAN encapsulation. Initially these things are not present there. Now we have these routes due to this VXLAN encap. Even I can check show BGP L2 VPN EVPN, and here you can see the type 2 routes here. Okay, and finally I can check show L2 route EVPN. So let me type it, yeah, EVPN, and then the MAC IP all, and here you can see the MAC IP and all the other stuffs that we have. Okay, so these are the verification commands related to our VXLAN overlay. In this section we have to configure our border leaf to external entity, and here is the diagram. You can see what I will do, that I will connect this leaf with a WAN router, and here in this WAN router we have server. We'll extend our network towards the WAN, and from the WAN server we'll ping our internal servers. So that is the overall goal here in this particular section, and here you can see all the steps that you have to do it. Okay, so let me go and configure the leaf device to connect to the WAN router, and then I will configure the WAN router to connect to my leaf edge. Okay, so let me go and log to the devices. Let me first configure my WAN. So here is my WAN router, and in this WAN router the interface is say gig 2, where first of all let me set the MTU value. Description is connected to leaf say 4. Then the IP address is 17.255.255.255.252. No shut.
do the ping. So 10.0.0.18. I will do the configuration from the leaf 4 side as well, and then we'll check the reachability. Let me complete this section first. Here I want to do IP OSPF network is point to point. Okay. And we have already done the no shut, then it's okay. From here I can exit now. I can go to router OSPF say 1. The router ID is 192.168.0.5. Then let me advertise the network 16.0.0.0.3. area is 0, and then I can check show IP OSPF neighbor. Nothing is there. Let me go and configure leaf number 4 as well. From leaf side I have to do the configuration. So interface E say 1/3, MTU is say 9216. This is under VRF member tenant 1. IP address is 10.0.0.0.18.30. That's the subnet mask. IP OSPF network is point to point. IP router OSPF say 1 area 0. Finally no shut. Then I'll go to router OSPF 1 and then VRF. This configuration is already there. Okay, now if I go to WAN router and let me check the OSPF neighbor, that is there, that is full. And if I ping, so let me do the ping test as well. So we have the reachability. Now finally what I will do in this section, I will configure the server number 3 same way that we have configured our server 1 and 2, because this is a Linux machine. So sudo if config eth1 172.21.1.10 is the IP address. Net mask is 255.255.255.0 up. So if any problem is there, it will throw an error, correct? And here we can see that we have this spelling mistake. Then I'll go and add the route. So route add net 172.21.0.16 gateway 172. So let me type it properly. 21 1.1 device is Ethernet 1. If everything is okay and correct, let me first of all ping to my gateway, and you can see I have the reachability. So I'm going to stop here, and in the next section we'll see that how we can add some more configuration for the redistribution, and then finally we'll do the end-to-end ping test.
Hi there. Thanks for your enrollment. We are in 1 minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy. And if you're going to enroll my courses, you will get 95% discount. Every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCI Data Center 3.0. Those are the new uploads as well. So please go continue your learning, take the coupon, enroll my courses, and study well. All the best. Hi there. Thanks for your enrollment. We are in 1 minute ad break. In this break, I'm going to show you that I have so many courses uploaded over Udemy. And if you're going to enroll my courses, you will get 95% discount every month, 3 times. First week, mid of the month, and the last week of the month. I am sharing the coupons. If you go and use those coupons, then my courses related to CCNP, related to CCI, all those courses, you are going to get heavy discount up to 95%. You can see the prices are a little bit higher here, but if you go and apply the coupon, the prices will go rock bottom. So go use those coupons. Suppose if you don't have those coupons, then you can always ping me over YouTube. You can send me email. You can ask for those coupons. I will provide you that coupon. So get the coupon, get the discount. Some of my courses over Udemy, they are bestseller. Some of the courses are quite new, like SD-WAN automation, DNA automation, CCI Data Center 3.0. Those are the new uploads as well. So please go continue your learning, take the coupon, enroll my courses, and study well. All the best.